Namaskar, good morning, good day. Salam alaikum, wanakkam, namaskaram. This is Engineer Suraj Singh speaking from Bharat, India. On this day, September 9th, 2020, one more day of life and this discussion about certain issues of our country and other countries related to COVID, management, engineering, general life, and all that I think is feasible, that I think is acceptable for public interest and engineering interest and engineers' interest. All those issues are very important for our society, for world society, and for engineers because quality is required, safety is required in profession as well as in life. Without that, cannot say anything. And an institution of engineers India, Bharat, that I belong to as a corporate member and certified by under law this institution as Chartered Engineer India and Professional Engineer International. And this institution of engineers, this day is very important because on September 9th it was granted Royal Charter 1935. This institution was established in 1920, according to you can see with this logo. And in 1935 it was granted Royal Charter, and with that I can say we can continue about this because that Royal Charter is an important document for this, for its statute, for its power, for its statutory entitlement. It's a statutory body, a constitutional body according to law because charter means constitution. We say Constitution of India, Constitution of Bharat, or Magna Carta of England, or Magna Carta of Venezuela, whatever we call it, that is the same name as the Constitution of this country, which is Magna Carta of our country, or Charter of Public Charter is the administration of India, and that's why it's called right. It's called Public Charter, and that was called Royal Charter. Now Royal has been replaced by Public, so you can say this is Public Charter. Institution of Engineers India. This is equivalent to Public Charter and officially still named as Royal Charter 1935. That's we are going to discuss in here. This is something else. And COVID is moving as it was moving before. It's intensifying every year. It's revisiting all places. It's reinfecting people, and that's happening. And that shouldn't have happened, but it is happening, and no one can say anything to this because this is what it's doing and no one can even control it. And we are being a sleeping society. I always call myself a sleeping society, and I think I'm right to that extent. We have proven now, we are proving that we are sleeping a lot. Well, this is not in my hands. We are sleeping, that's true, and we should not, but we are. Well, I alone cannot do anything. I can only do something to help myself, to help others, to help countrymen, world people, what we are doing. And this is many programs that I'm seeing on this. Titles that we may discuss, we may not discuss. Thinking is very important for me. And then I can say, yes, it's okay, fine. We have to do something like this. Whatever we can say, we can say on these issues, we can daily, I tell you. And I did not revise this file, but I will revise sometime. Now because many issues have come. But still COVID is a very important issue, and I can say that we have to move with that. And today I start with Institution of Engineers India because COVID is working very well. I'm you can say satisfied. What I should say, I am satisfied with performance of COVID. You can say because performance is very important in engineering because profession it is. I think only profession other than you can say other than medical where performance means something. If you perform, you can say yes, you are performing. And engineering demands that. Engineering demands performance, and it's that engineering demands performance, and that performance is very well here. Performance in engineering Similarly, COVID is performing and we can say that it's doing its engineering, that's in joking form. So we should not be angry on that. After all, it's without permission of God, nothing can happen. Even epidemic cannot be there, pandemic cannot be there. So it's there, and we are enjoying this now. People are enjoying, so I can say we are enjoying. Government is enjoying. Nobody is serious. I'm not finding 1% people serious in this country. Unfortunate it is. We are still sleeping in such kind of critical time. In this kind of, because we are sleeping society, a relaxing society, non-serious society. So I'm happy that what I used to say in the last videos, many last year, that we are really a wonderful society, that we least bother even anything. 43 lakhs or 4.3 million people already affected by this, and they are talking of recoveries, like parrot talks. Our government has become a parrot. Recoveries, just like Iran says recoveries, and just like many other countries say recoveries. I don't know what recovery. If you see Iran website always saying recoveries so many. If you see many other countries recoveries so many, they don't understand what is recovery and what is cover. Cover and recover, what is that? They don't know, but they say recoveries. We also don't know recoveries. We just feel happy that we are not dying. Means because we assumed we will die, so we are not dying. Child, still child. You have to justify your non-performance by whatever way you want to justify. You say that means if 96 people die, you don't worry about that. If 4%, so 90 people saved, you don't worry about those who die. You don't get saved. We say 2% died only. So what is 2%? Is that not a say? Why did they die? Okay, if they die natural death or by their own some other disease, that's different. But if they die because of COVID, what does it mean? This means why even 1% is dying? Question is that. Every country speaks same language. America same language. England same language. And means as if they are perfect. They don't want to take any blame. Human is not happy to take any blame and to accept mistakes. They forget if you accept mistake. If you accept your fault, you are a great man. Because fault always stands with you. It does not go away. If there's a default, there's a fault, there's a mistake, this means you are a good person, you are working. And if there's a repetition of same mistake, they are reverse person, you don't think, you don't take care, you don't precautionary measure, you don't learn anything. That's what is happening. 8%, let us say, 8% infections are being uncovered, are being extracted from tests. Why 8%? Why not 1%? This means you ignored somewhere. You ignored. Don't forget, it's a mass. It's a mass country, masses country. 130 crore or 1300 million public. 8 crore means what? 8 to 10 crore say you can exempt someone out of that. Still, if you 100 crore into consideration you take, you will get 8 crore or 80 million. I put this on Government of India website also, my Government of India. That you are not doing anything, you are inefficient, you have failed, you are not serious, and that's why your public is not serious. If government is not serious, public is not serious, or public is not serious, government is not serious, this is both are not serious. This means what? Neither is responsible. Neither government is responsible, nor people are responsible. So who is responsible? Automatically you will say, God will take care. Yes, God shall take care. That is exactly what I want to say. God shall take your care also, don't worry. Right? God shall take your care, Mr. Government. You do your job, you are paid for that, you are not doing your job. Administration is your duty, execution is your duty, policy making is your duty, controls is your duty. What's not your duty? Tell me. You are not doing job. That's why this number is rising. There is a confusion among people. Some people say there is corona, there is no corona. Why some people say there is no corona? Because they are not clear about this. That's all. If some people are not clear about emergency or about impact on them, they won't recognize them because they are not subject to that. If 8 persons are subject out of 192 people, shall not worry, this is happening here. 8% attack is here, 8% people are impacted, so 92% people do not understand what is impact. Even in the reverse, they would understand. This is only reason. First of all, we are careless, we are ignorant, we don't want to have knowledge, and there is no teacher, no advisor, no instructor to tell us what is required, what is not required. All intellectual levels are not same. If there are 100 people, there are 100 levels and 100 different ways of thinking. So they think, oh, it's nothing, and nothing. And that nothing plus has become emergency. So we are moving through that phase of life. Very critical phase. We are now number 2 in list of infections. We are number 1 in list where we say daily infections are this. We have plus 70, plus 80, plus 90. In these 3 ranges we have been moving for last fortnight or 2 fortnight or month, you can say. 70 plus, 80 plus, 75 plus, 85 plus, 90 plus, and maybe yesterday it was low. Maybe some reason was there, I don't know what reason. Before yesterday, day before yesterday, it was 90 something. Before that day, 19 something. Before that day, 80 something. Before that day, 83 something. Before that day, so it is gradually or ingradually or heterogeneously moving on that figure. It's no more 1,000 or hundreds. So we have crossed that datum, and therefore either we should enjoy it or we should improve on its attack. We should re-encounter it by resorting everybody to precautionary measures, but people still least bother. Now, people walk here and there, travel here and there, move here and there, when you see on road, vehicles and vehicles and vehicles. I don't know. People are very busy and economy is at sea level, at ocean bottom. And we say, we are very busy. I don't know who are busy. 80% people are now having no future. Only 15 to 20% people have future, who have plenty of money and plenty of whatever you can say they have. They least bother. But workers, farmers, vendors, small hawkers, and people of lower middle class, they are still in problem. They don't know what to do. Youth are crying, everybody is crying, but there is no ear to listen to them. There is no mind to understand them. And that status of my beautiful India, Bharat, and COVID has taught it very good lesson. And still it has to learn lesson, but unfortunately teacher is working, students are sleeping. That's happening. My government is to be blamed for this, and directly blamed for this, because government is not doing its job it is supposed to do. Just making statements on computer, on internet, or on news, it doesn't solve problem. So I have to say, it's better forget government, you become your own government, and you do whatever you can do in a way that you can get escape from impact of COVID-19. COVID-19 shall not go so easily, forget it. So you have to understand it and live according to its in requirements. What it says, you live like that. Otherwise, it shall impact you. So I have no more to say except that world is in still problem, has not gone out. Still problems are coming every day. This mad PM of England tried many things, he failed, people are cursing him. Same thing, this mad Trump, he says to one journalist, remove your mask, see fun. Remove your mask, I will talk to you only then. That person did not remove mask, I salute that journalist he did not remove mask, even Trump asked him to remove. That is called journalist. Trump asked him to remove, and then he's laughing on that, enjoying on that. So I think Trump, person like Trump being psychopath, a person like Johnson and person like our PM, they're all in same class, psychopaths. They are. Now we can start saying that they are psychopaths. They don't understand problems. They want to enjoy and entertain. When people are in problem, we are facing problem. So now come back to Institution of Engineers India. My institution means I am member of that, corporate member of that, and I am also one of those educated engineers, or you can say Bachelor of Engineers equivalent. I qualified from this institution. My degree, before that I passed a diploma of 3 years diploma from Board of Technical Education, Delhi in 1974, and then I had to pass, only way was that time to complete your remaining portion of degree from this institution, that is called the Institution of Engineers India Bharat, whose head office is situated on Calcutta. I passed from Delhi, but examinations are conducted by Kolkata head office. That is practice and that controls everything. All people report to Calcutta and they appear examination. This is called Section A and Section B examination of this institution. When you pass both sections, you are given equivalent right to a Bachelor Engineer or Bachelor of Engineering, or you may say a normally qualified degree engineer. So Section A and Section B of these institutions are to pass in those sections equivalent or equal to degree in engineering from IIT, it may be from other institutions, maybe from universities, wherever it is. It's actually recognized as that. It was established in 1920, and then it was granted Royal Charter in 1935 by King George V. Of that time, British came, and since then it has been working in capacity as a statutory body, or you can say constitutional body, that is called chartered body, Royal Chartered Body. This means this has been an institution in patronage of King, under ownership of King, though it's a corporate body, it's a public body, yet it has got powers from King to certain empowered like you can promote, you can advance engineering, you can promote it, advance it, and do whatever you want to do in application of engineering, profession of engineering, business of engineering. That is its objective, and for that purpose it can qualify engineers, it can test engineers, it can go to whatever extent, it can conduct seminars, congresses, journals, like can maintain libraries, it can do research work, it can do arbitration work, it can do scientific work, whatever is in purview of engineering is. There are 15 branches now, 15 branches of engineering which this institution cares for, and this institution is a member of many international bodies like World Environment, and one of main important is that it's a member of IEEA, that's International Professional Engineers Association, or you can say agreement, actually, I'm sorry, not association, International Professional Engineers Agreement, which is equivalent to international statement or international authority for controls on professional engineers and international professional engineers. 15 members are there. One of them is Bharat India, and this body was previously known as EMF, that's Engineers Mobility Forum, and but because it's a member of that, so Institution of Engineers is Indian representative to maintain register of international professional engineers throughout this country, and that authority is given to us, and it can conduct examinations of those candidates who have aspiration for getting this title, International Professional Engineer, and also to maintain register of those who conduct their examinations by writing and also by interview, and then it issues certificates which is valid for 5 years, and then you have to renew it, and same also it does same for professional engineers as well as chartered engineer is already there. If one is corporate member, if I am a corporate member, I am a chartered engineer. If I wish, I can write that because it is provision under charter on charter, which is a part of statute and constitution, that every corporate member can take and use name of chartered engineer India. This is the provision in that. There are so many other provisions in the complete royal charter. Royal charter means written grants given to individuals or by to bodies, by law or by government or by government means king. So that is or royal or whatever you can say. This is now royal. This is though institution we may say royal charter, but now it's presidential charter. You may say it's constitutional charter. You may say, or it is a public charter. It's still a charter. It's not funded by government. It's a self-funding body. That is basic requirements of charter. In that time, it still is there. If you want to have a charter in UK, you have to be independent. You must have 5,000 members. You must have adequate money with you to maintain your expenses, and all those members must have 1 degree at least. That is basic requirement of charter, and this is granted to universities, granted to institutions and bodies like this institution, particularly educational bodies, research bodies, religious bodies. This charter is granted to them. This is nothing but you can say a kind of higher profile statute, and our many courts have stated that this is a statute and this is on record. So this institution was established in 1920 based on report by Industrial Commission that for promotion of engineering in this country, India, Bharat, that time, we need some institution, and this commission, which Industrial Commission it was called, this reported, and then this under Companies Act 1913, this institution was established and inaugurated by Governor General, you may say government, and this started in Kolkata, Madras I think, and then migrated, relocated to Kolkata. So later on it became Royal Chartered Body in 1935, and now it's 85 years of Royal Charter. What we have achieved, that we can only assess. I'm not going to that, but we assess today is that day, September 9, 1935, and also after I can say, after 6 days shall come, Engineers Day, Dr. Sahib of Karnataka, Vishwesarya, who is also a legend of engineers, and you can say a guide to engineers. That commitment is more important than degrees. You have to commit, you have to devote yourself to duty. So that is what we say, institution itself says, you have to do. The institution is not comprised by council. Council leads it, council executes what is required on charter. It makes bylaws and all laws and rules and grants and says who should be a member, who should not be a member, depending upon qualifications, academics and experience. And also it does issue certificate of qualification examination to students who can qualify, and also it does conduct many dissemination of information, which are called seminars, or you can say congresses. It issues many journals, technical journals, and so much publication is done by this. Now it's in alliance with the Springer journal, So this has advanced as far as I can say, as far as technical dissemination information is concerned. It's done well. It's done well at very high level, journals and news and publications, all that. In that, I think there should be no I can say question or reservation. But students also pass from this institution. Like one of them, I am, and I can say that its examination standards very high. It's much more higher than people can think of. That's all I can say. Even IITs may not maintain that standard of examination which this institution does, and I have pride in that. Institution of Engineers India is honest body as far as educational process and examinations are concerned. There can be no cheating, and even they don't give any concession. There is no objective that they should have so many percent pass. You pass or you don't pass. It's up to you. If you get 0 means 0. If you get 49 means 49. If you get 50 means 50. They won't even give you 1 grace mark. If you are 49 in Indian subject, they will declare you fail and you clear. That's what is required as a standard. This is not government owned body, but this is government ruled body. Yes. It's a kind of government in itself, you can say. Royal Charter means that. It's a kind of self-governing body. There's an executive council on this, which is elected by members itself, not by outsiders. Every corporate member means one is definitely, you can say, engineer. And this AMI is first number of corporate membership, MI is second number corporate membership, and FI is top, you can say, third number corporate membership, which have very varying qualifications and experiences and age. And AMI, MI, FI, these are statutory titles, charter titles given itself in AMI and MI are given on charter. FI was introduced in 1974. So when we use our name, this name, and then we can write Chartered Engineer India and that designation, that's complete now. So if I say FI, then there is no need of writing degree or ME or PhD. No, you write, doesn't matter, but it's clear indicative this all education is amalgamated, is merged in these titles. This itself indicate what what's your level. Your MI means you must be young. I mean, I don't say that's necessary, but with presumption according to design of these regulations, we can say young and middle class. You may say at those who are advanced in engineering, then middle engineering, and you say final, and the final go out. So it's like that. So fellow means a person who is senior, and man means middle class or middle age, and age means advancing. So advancing person is young one, of course. And so this is that charter, and I have studied from this institution. I passed my degree in 1980, and I understand this institution very well. Though I'm not a member in council. I'm not in their that active politics. So I don't want to play politics. There may be some politics because generally when a group of people are there, they have every. But performance is more important. I find performance is excellent, except in one way, that they have not been able to do something for this chartered designation, because people do not know what is chartered engineer. They know chartered accountant, they know other charters, but they do not know what is chartered. We should not forget that there was a time when our law ministry was also given charter by England. That's our ministry was given charter. Our course in Madras, our course in Bombay, Allahabad, and I think many more were given charter for their functioning, and still these courts are under charter, royal charter. This High Court of Madras, High Court of Bombay, and High Court of many other states. And one time there was Supreme Court, called High Court actually, and that's also charter. So those times are still there. We can remember what's meaning of charter. Unfortunately, charter is not part of education of law, so that's why our advocates are little low in its criteria of understanding. Maybe judges know who have been old and they understand charter. The meaning they understand, but what charter is, what does it mean? They may not understand. They may say this executive order, this is that order. That's not the case. This is judicial order. In fact, king uses judicial power to issue this warrant. This is warranted, and this charter is that. So I just trying to explain. I will give you complete talk on this issue later on through my presentation. I made that presentation long back, not now. It was made, I think, in I don't exactly remember, many years back. It was maybe in 2013. I did that. So still it's online. I think I have put URL also of that somewhere in this in this text of my video. So that was I wanted to say about her, just for information of public, that Institution of Engineers India exists as a professional body, as not as a university. It may have its own university later on, but it's a leading body only professional body in this country which was granted oil charter. There is no other body which was granted oil charter except judiciary, high courts and law ministry of this country. I don't find something else there, anything else where charter was granted to someone. So this is, history. Every engineer or corporate engineer should draw pride from this, that you are having statutory status. I'm not saying power, I'm saying status. If you are a corporate member of this institution, this means you are a statutory functionary, you are chartered engineer of this country, and you can use this charter for professional development, for signatures, wherever you can do designs, it may be quantification, whatever engineering function is there, we can use this, and you are known as chartered engineer India Bharat. That's every corporate member is, and because it involves everybody can be corporate member who has certain defined qualifications, demanded qualifications. So I think this is enough for today's talk. I congratulate all members of institution and public of this country that this institution was first to be granted oil charter, and still that charter is valid, though there is no amendment to that. That's defect of our country, that once we get something, we do not look into that. It should have been amended every 5 to 10 years, but didn't happen because of slackening act by council of our country's institution. Institution is slackening members, lethargic members, I can say. They do not, still they say they will conduct some webinars, but they do not, might be they have not gone through provisions of charter, but they will conduct some. Well, congratulations to every one of us, sabko badhaiyan, all engineers or members in this country, as still that oil charter is working. It's not been dissolved or restructured. Until that time this is valid. So we should congratulate ourselves and drop pride, and we have to determine that we will serve this nation honestly. Engineers should work honestly because you are in chartered status, and if you cannot work honestly in quality, honestly means you have to maintain quality, and if you cannot maintain quality, then this means you are not serving your country. To be very frank, I do not like a person who doesn't care for quality and being an engineer. I can excuse others, but I condemn every engineer who does not deliver quality, who does not force people to do quality. This job of an engineer to force everyone to do quality, otherwise management lapses, otherwise organization lapses, purpose for which we are living or working that lapses. So that's why I can say, going back to management and organization, I can say again and again in continuation to this, that very important presence of mind, active status of mind, objective of mind. Engineering, what is engineering, definition of engineering, and according to charter definition is that apply engineering sciences, apply engineering in the small business of engineering, promote it, apply it, and do as much as you can do on that, do research work, or you can say innovative work, and we move ahead with improvements. When you move, say engineering is such a world, when you move and move and move, you get automatically more and more and more. That's beauty of engineering. Engineering is in industry, we call it industry, INDUSTRY. What has been in dust, it is industry, and you have to come out of that. So when you work in industry, means you are working in dust. From dust we get every material, and when we use that material in the industry for production of whatever equipment or whatever item we do, all comes from dust. That's very clearly industry it is. So industry means engineering. Engineering applies on industry, it applies on trade, though not that much on trade, but on industry certainly it applies all engineering disciplines, civil, electrical, mechanical, agriculture, whatever you can say. Wherever there is industrial involvement, you can say engineering is there. Without engineering, industries cannot move. Industry means engineering, because industry gives you product. It's not simple business, it's not trade that you just exchange money and you get more money. It's product, and that product has to be used, and it can be used only when it is sold, and it's sold to him as qualitative. If it is not qualitative, you may sell one time, second time, third time, person won't be cheated. So industry is something else, and industry is actually engineering, you can say, construction engineering or mechanical engineering or electrical engineering or production engineering or whatever engineering, agricultural engineering, aerospace engineering, electronics engineering, whatever you say, everywhere you have to deal with product. Civil engineering products are so many products, they're very big projects and very big person. Let me say it's not one day, mechanical product can be one day production. Then these products are collected and assembled according to circuit or according to that process, which the mechanical say process or chemical engineers also say process engineering. But our processes are very different. Being a civil engineer, I can say that, and I associate mechanical engineers and electrical engineers with me, because without them I can't move as a civil engineer, even if I am doing some infrastructure work or whatever, even if I am doing road work where streets lights are required and where I think minimum is a street light and signals, you can say signals of course, and you may say there may be some other, for example these days so surveillance is also required on those highways, where there is cameras and radars are located on many roads, and that's in Gulf countries particularly. You can see radars are only many highways which is record your speed of car and automatically issue challans, and the notes also, you can say image, captures image. So that's, you can say that other surveillance engineering is also attached to you, and that's one way good, because engineering is advancing, techniques are advancing, and we are using them, we are learning from them, we are update ourselves, and that's one good idea of engineering. Gives advancement and keeps on changing, and engineering is change. Engineering means change, and change is change. I say every time, engineering means change, engineering means challenge, engineering means intelligence, engineering means hunger for knowledge, and engineering means do best product, create best product, produce best product. Again I say product and product, goods and goods. We convert natural materials available into products, into modern products. Products are always modern, we say modern, not modern. Into useful product, into, you can say such products we are friendly with environment, and we are non-carbon dioxide, non-pollutive, non-plastic. Such products are of course certainly in favor of nature, and we use them, but we have not used them properly. Now life has been plasticized, we can say. We are living in a plastic world, and before that we were living in a steel world. Now it's plastic world, and before steel was timber world. So you can say timber time was there, steel time was there. Now when fiber time came, now it's plastic time, and now it's corona time as well. So you take that into I have to link back to current problems. It's very important. We have to think of corona so that we think of life. This is how we have to survive, how we can exist. So corona is a clear declaration that we are responsible for the battle with to this earth and environment. We are responsible for that. We should not deny this fact. If we deny this fact, we kill ourselves, our minds. Everybody has mind, and development of that mind is enlargement of that mind. It's very important point. Sometimes I find myself, why I am in engineer, I get answer myself, because I have to do something for this earth. That's why God pushed me to be engineer. I did not become a doctor, I didn't become something else, because maybe my soul suits to engineering and not to other professions. That could be one of point. But still I am saying, I am not finding souls are proper. Means why only this country? I have wanted to raise this question all the time. Why only in our country quality is ignored? That's my question. Very important question it is, and it has to be answered by those who are in engineering and who are also not in engineering but are related to engineering. All those people, why don't we comply with systemic quality? That's big question mark, and only engineers can answer this, and this is because they on Royal Charter we have to answer it. Why don't we produce quality product? What is problem here? Are we saving money? Are we doing good for ourselves if we do not comply with quality, or we do not know quality? This point must be understood. If we do not understand quality, why don't we understand quality? Question is that this is our basic job, because we are engineers. If we do not know quality, then there is no meaning to, there is no one out of ourselves who are engineers, who can be said engineer. If you do not understand quality, if you do not apply it, if you ignore it, you just do what is done or how people do, you do not instruct them. So you can say that you are not an engineer, not at all. You may have designation, you have everything, but because you are not doing service to people and service to world, service to earth, you are not engineer. Your job is that you think of quality, you do quality, you produce it. That's very, very important. Quality is very important issue when we talk of engineering products, and not only engineering products, other non-engineering products. Example, for vegetable you buy, some betel you buy, or some food you buy. Even you see quality or don't see quality. You see quality, then you buy it, or you do not use it, you do not buy it. So same thing happens here. If I have to be very serious for 5 kilogram vegetables to buy, and I see quality where I spend only say 100 rupees, why I buy something where I see quality? When I travel something, I say, oh, this should be clear, this is not clear, not hygienic. I don't see this cabin is good. I find so there's no way, cleanliness. Hence, when we spend very small sum, we do not talk of quality. Talk of quality, but we spend lot of sum. Say you want to buy a flat or apartment, or you want to buy something else. There you are least bothered about quality. Why this difference? That's the point. Means you cannot say that if you talk of quality, you are a bad person. You should not say that. And you are not talking of quality, you are a good person. You should not say that. It's not question of good person or bad person. It's question of quality compliance. Quality compliance means whatever you have accepted, or your profession accepted, or goods practice have accepted, whatever is there, that must be taken care of, and that is what is required. That was an important point here. You have to understand that. So it's 4 o'clock. So no problem, 4 o'clock or 5 o'clock. Life moves that, and I am very serious about quality, to be very frank. I am lucky to have learnt a lot in quality world. I'm not saying I'm expert on my professional quality procedures. I'm not quality engineer as well. I am total, you can say, it's not ISO 9000 I'm not talking about that. That's something else, That's a system quality. System quality means ISO 9000, you must be knowing that. It's a system, definition. It says that you have to make a system, you have to establish a system which is based on certain quality criteria, and that is very different one, and it is assumed that once system is established correctly, professionally, of course quality is a part of system, procedures are part of system, and conduct is also a part of system, conduct of everything. So that quality is something else. That quality is system quality. It's not a nuclear quality. That is systems quality, and that quality is what we are talking. Of course, system we are talking. We have no systems here. Means whatever we have, we call it system, but in fact, that is not system. And wherever it is, it's only for namesake, not for implementation. And that means quality depends upon performance of system, functionality of system, and if you do not establish system, then we cannot get quality. Means it's like a car, or where you sit down and then drive, or you are a passenger. Car moves, car works, and you are also moving. So you do not doing anything, you are not doing anything. If you are moving in a flight. You are doing. I'm flying. I'm flying. Yes, you are not flying. Flight is flying, but you are flying. Same thing is saying, when you flow in a system, you work according to system, you work according to methods, and according to all of the required to comply with all those. That's called quality. And product which comes out of such, and you can test that product, you can find the satisfied test, can say quality product. So this quality system is very, very significant for engineers and for public as well, because engineers are functionaries to make this material product and sell it, or who sells it. ultimately consumer who buys this material, that consumer must be happy with that, must be pleased with its performance and be satisfied, and that is customer satisfaction goal. Customer satisfies because maybe customer sometimes does not understand what it should give, but we have to understand engineers because we are responsible for that. And only engineer can do it, others cannot do it because others are not qualified, not educated to that level. They can understand what quality is. And only engineers, maybe I can't say they can understand, it's engineer who can understand only whatever level of education one is having, but quality engineer understands very well. And one cannot deny this fact. If one denies, and I call you are not an engineer, go to school and learn. If somebody says I don't understand what is quality, so you are engineer, you are cheating yourself. You know it, but you are denying this fact. Okay, you missed something. It doesn't mean you start here. Okay, I missed something. I have to repeat that also. I come back and study at home. I missed some lectures. We do okay. We can cover it up. But engineer means you are a man of quality. You are a man of product quantity. You are a man of budget. You are a man of everything. You are a man of, you can say, whatever comes in profession, whatever done is done in profession. You are performer of that. In whatever field you work, in engineering, electrical, mechanical, civil, architecture, wherever you work, everywhere work is done, and work is done for useful purpose, not just for decoration or just for showing that we have done something. When work is done, we say we have to deliver that product for certain objective, and that if that objective is fulfilled, we can say we have engineered it. So that's another definition of engineering means. It's not simply what engineering defined on chart. Engineering common sense definition is that you are dealing with something in productive way in a way of a professional practice, and that's engineering product because that's engineering profession. And profession engineering means engineering itself is advanced, and we say professions of engineering means it's much more advanced, means everything is calculated based on experience as well, and it's a derivation of formulas and based on whatever you can say. Whatever it is done, it's complete profession of engineering, and once you join in the profession, you cannot come out sometime only at your terminal point where you have to leave this one. Otherwise, nobody can ask you to leave engineering. Even though you are in government job, you have to retire, that's something different. But as far as engineering is concerned, you can never retire yourself. You have to, a impeccable mind. That mind is very strong one, which means your engineering knowledge, maybe engineering experience, and that mind is very powerful. That mind must be used perfectly and without any reservation. And your mind is your power. Your mind is your electrical power. It's thorium, it's, you can say, nuclear power, it's nuclear radioactivity, material, and it's your mind. Your mind is a nuclear reactor, you may say one time. You can say that. I think it's nothing wrong because there's a chain reaction. Your minds are fission completely. Fission and fusion, two terms are used in nuclear engineering. And fission means when the explosion or enrichment, or there's a process of enriching all this uranium or that U-234, what it is, and you use that product, that chemical atom, and that continues thriving, and you get some answer from that energy. Energy is converted to some product. It's a very final product one. And that's why it's there. So we are dealing with product. Building is a product, road is a product, and you can say flyover is a product, and you can say car is a product, a bus is a product, and it's all production based. Production is a factory or on site. Site is also a factory for that project. You can say factory of site, doesn't matter, doesn't mean anything wrong. Because ultimately that's a site for you, which work with it for many years. Engineer goes to a site and works there for many years, so you can say it's a permanent product located at that area, and out of that product there are so many products you manufacture and you produce, and then that product, then foundation product, excavation product, then you can say this product, that product, and all these are in the same area. That's only, so this is a machine, you can say building is a machine, flyover is a machine. These are machines because these perform accordingly. Foundation part, then you can say step column part, then you can say fill part, and of course you can say slab and beam and all that. These are components, parts of that structure, or bridges, or you can say deck slab, you can say bearings or piers or abutments, you may say, or road on that, means all that, and you can say interlock retaining walls and whatever walls. Same you can say for railway lines, you can say subgrade, grade, and then sleepers and aggregates, rocks and sleeper tracks. So all that's in construction of platforms and construction of station offices, station buildings. all that comprising that. So engineering is such a vast means we cannot simply stick to one point education of engineering. You have to keep on moving and you have to go to there. You everything is on your tips in that level. That level is called informative level. And in now all engineering disciplines invite IT with them. They cannot move without IT. IT is very important there. We have to means think in the different mode now. It's not simply one what we say or what my teacher said or what my father said or mother said. We have to come out of that and we have to develop our science. Because engineering is development of world and development of personality, development of personality as well as an engineer. If you do not develop, you cannot develop further. That's another equation. You have to develop yourself first. To develop doesn't mean you wear good clothes or that. Develop is develop your mind, raise your mental level, increase your mental stamina, so that you can digest forces, in negative forces that come back to you in form of stress and rain. So you keep that stem trapped and continue working, because that strain caused by stress will not help you, just to oppose you. And that's where we say something is different. So engineering means something different. Engineering means you have to create something. Engineering means you have to amend something, modify something. Engineering means you have to deliver to society. And it just means you have to speak when it's required to speak. And you have to raise questions against why you are talking like this from responsible government. You have every right to raise questions and let person answer. That person answer means that person doesn't know that, just speaks, and that doesn't mean anything. If you do not know what you are speaking, why you are speaking, how you solve it, what way you have solved, what's the diagram you are charting to that, that point is very important. The engineering definition, and then of course quality comes in and thinking comes in. Quality and thinking are related. If your quality of thinking is also improved, you can think much more better. You understand that point? When I say thinking means we can say professional thinking. Thinking doesn't mean thinking how I should go to stop and by not saying that. It is professional thinking. Professional thinking is religious thinking. When I say religion, doesn't mean religion, Hindu, Muslim religion, means engineering. I always keep myself at a religion of engineering, and because it's my profession, I spend my life, whatever way I did on this, and irrelevant to how much money I earned, that's different. I don't connect myself, I don't recognize that view. The people recognize it very well. Okay, you recognize it, you do that, but I am pure in mind and heart. I want to remain pure. I do not consider that I am dirty. I consider I am clean, because at least once or twice I take bath. So sometimes dust even cannot harm you until it's cold, because also dust particles, clay, easily can enter your nose and then your body and can spoil something. So we have to be very, very clear about that. If for example, we use concrete for building, we use it and we know what concrete is, what steel is, why it is used, what's the criteria which is not understood so many thousands of years before. Now we use that. So what I say is that we have to become an engineer if you are qualified one. The engineer is only service that you can deliver to God. Best service is engineer, and engineering is very, very important. That must be done, and I think that is very, very good that we do that. Engineering means engineering. Engineering is world, and engineering means everything. And if you do engineering means you serve people of this country, you serve this world, and when you serve this world means you serve God. Whoever God, that's up to you to decide. I'm no one. God is everywhere for me. God is in my speech. God is in my clothes and my body. God is sitting everywhere. That's why I am speaking. I am doing. I am alive. If there's no God in me, I cannot do anything. I shall become a dead body. So my engineering is that this is I control myself within this body by some power controls me and gives me food as well. And I can say that I am a product of God. You are a product of God. We should not forget God is there without any name, without any religion, title. I take God into myself. I don't need any religion to understand God. I don't need any other way to understand profession, because profession itself means service to God, and service to God means prayer, And work is worship, not prayer, not mantra, or not something else. That is, of course, people do that. I accept that. You can do that, but this doesn't mean that you know. It doesn't mean that we should do something else. We should do something else. I only can say that. I only can say that we should be smart enough to we should be smart enough to use to make use, or we should be available all time with a pleasantry manner that God uses us for development of earth. Thinking for me is very important. I trust thinking more than my conduct, because thinking is something which does not need any money, and thinking is that one that powers. And if you think that power is you have power of thinking, then I don't think that there is something else you need. That power of thinking is money. Means not money in monetary terms, but money in your wealth terms, wealth of nature, wealth of soul. Thinking is that property of one, and this is not simple property as dictionary says. This is something else. This is property of power of soul. You can think only if your soul is powerful. Means you are not in depression, you are not in level field, you are having a mound on you, on your soul, the mounting of soul, which is very, very powerful. And if you can develop your soul, I can say you develop yourself. And the soul is burning power, soul is energy, and that soul gives you gift of engineering or gift of whatever profession you are in. This engineering helps you there, because engineering or medical or whatever you do, you understand. Your soul understands that. That's why you do it. Because your body cannot understand that. Because body cannot go to that extent as soul can. So I am just talking of soul, not because it's talk, but soul should be everywhere. In my work there should be soul. When I work or when I don't work, when I think, thinking is first requirement. The soul forces me to think. Soul forces everybody else to do something. And this is the soul that takes us to heights. So we should clearly understand system of soul. We should clearly understand systems of body, and we should understand system of body between that and that. Whatever portion of life you have to live, that portion is very temporary. It can go any time. So we can say that. You most welcome, dear Safi. What I do now. Okay. So life is different without thinking. Those people who think they enjoy life, not physically, mentally, spiritually, you can say holistic way. My holistic way is not worship in mandir or temple or prayer, mass or just something. My is that means you can say that I am a different person in that way. Maybe you do not like that, but my God house is here. It's not is here in every part of my body. My God house is not in any building, because in building God does not stay. God stays in heart building and mind building. God stays there. So I don't need any building for God, because I am living in a building, and that is this building, and this building is in another building, that is this building. So building and building and building and building, there are so many buildings. This means buildings are not strong enough. Buildings don't have adequate accommodation to let God occupy that. But heart and mind have enough space, God can use them. So my thinking is that think about work, think about improvement, think about time study, think about best coordination, think about best communication. Do not think of wars, do not think of enmity, because wars and enmity shall not help me. My functional work, my innovative work shall help me in life. This life is very different. We should realize that fact. This point I just wanted to discuss with you about thinking and challenges. Challenges, of course, it will not tell you the challenge has come, but it's working with you. You'll find some time. Oh, challenge has been working for me. Yes, challenge has been working for you for long. You don't try, you cannot get it. You try, you can get it. It's up to you. So when I say engineering comes back to engineering after thinking, and thinking is the unit of engineering, thinking is procedure of engineering. Without thinking I cannot do engineering, and that's what I understand by this. Every day don't be bold when I talk this, but this is very engineering. Engineering is very, very vast subject. It's a discipline, not only it's all, you can say world is complete world. And engineers are those people who take group of these people, or I can say world creatures, to their display of people, their workshop of whole places. That's what to say. We are all people, we are all learned people. If you are not learned, we could fight and solve problems, but once you are learned, it's very difficult and impossible for you to track back to your status with you are this mask or something will not help you. Even you do that. So engineering is very important, and I'm very concerned with this, that life is moving but people are not moving. People are only interested in wealth, and it's very, 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 wealth means it shall come to you, it's due to you, but just you want wealth, for that you can go to whatever criminal standards you can go to, you can cheat police, you can cheat people, but one day you shall realize that it is all wrong, and of course you will be sons in cheating, or you can say in attack on using fraud. So I don't think just enough for something, enough for this thing, that thing. We have to be very clear about science, about changes, about challenges, about material, about whatever you can say. As engineers, engineer job is not very easy. It's a job where you have to do something with no knowledge of mathematics and knowledge of physics and chemistry. You can do that. You have to understand every word, every act that's seen is what we have done. Just blaming system is nothing. Since my childhood, I have been watching. Somebody talks of systems and they talk of changes, and whole public walls are put on by those who are saying posters. We do not need that. We need clarity in understanding. We need improvement on quality, and that improvement is very important when technologies are advancing, but it's not happening. It's really not happening, and this is regretful. I can say my statement is, I am generalizing, and yes, I have to generalize, because up to 66% page passes, it's generalized. Generalized means you can say pass marks is so low that everybody shall pass it. So I don't want that stage. I want people should be really active with God. People should respect what is God. God doesn't mean religious God. I say it's engineering God, or engineering God is different. So I will now go back to soil mechanics and soil. I did yesterday as well, talk of foundations of massive blocks. So I will be back to the part of soil. Soil, again I say, I can't define it, because soil is such a powerful material, powerful subject. It helps everywhere, and when something helps everywhere, either it short circuit and run away, or it continues the whole night, whole day. So, try to in it, but we cannot. So what to do now? Let's go back to our system system of stocking, that is soil, and see how it works. If I think I was talking of not soil exactly. It's talking of machine foundation, right? Machine foundation I was talking of, and I was somewhere around where it was it's talking of what? Yes, we have gone to this naval land. It was this one. Let's discuss this very briefly. In fast movement, we discussed this. And I was here, and you can say, it was for summer, I think we were talking. I stopped at that point, depth of the calculus. So I should say, again, I can read this paragraph. It's long or no? Oh, it's not very long. I can read it better. Which was frame foundations. That's I'm talking of machine foundations. Frame foundations are generally provided for high-speed machines. Frame foundations, I can say. Says that frame foundations are generally provided for high-speed machines such as turbo generators. Turbo generators use of frame foundations facilitates inspection. Recently, it has been suggested to limit use of frame foundations to low power turbodynamics, turbine dynamos up to 12,000 kilowatt, and to use massive foundation for high power dynamos, but it's not always correct, because in many cases frame foundation has proved to be cheaper than massive foundation. Massive block, you can say. Massive foundation suffers from another defect, that very often cracks are formed due to settlement or by temperature changes, whereas cracks will not develop in frame foundation. A frame foundation is usually designed to be built of 3 or more transverse frames embedded in a sufficiently thick foundation slab. These frames are tied together by longitudinal girders at top. An upper platform is made for stationary machine parts. Geometric layout of foundation, shape of girder, cross sections, etc. should be symmetrical with respect to vertical plane passing through axis of rotation of engine. From frame beams should be kept just under bearings. Frame beams should be kept just under bearings so that centrifugal forces are transmitted directly to the transverse frames. Frame beams should be kept just under bearings so that centrifugal forces are transmitted directly to transverse frame, axis of column and transverse beams should be in same vertical plane. Same vertical plane and perpendicular to rotation axis of motor. Should be same vertical plane and perpendicular to rotation axis of motor. Eccentric loading in transverse girders. Eccentric loading in transverse girders should be avoided for preventing torsional stress. Direction of load should pass through center of gravity of cross section. Depth of foundation under machine may be smaller, but lower foundation slab must be rigid to secure proper embedment of foundation columns. This prevents non-uniform settlement also. Presence of lower foundation slab having considerable thickness, it decreases height of common center of gravity of machine and foundation. Thickness may vary from 0.8 meter to 4 meters for very powerful machines. So presence of lower foundation slab having considerable thickness decreases height of common center of gravity on machine and foundation. Thickness may vary from 0.8 meters to 4 meters. Foundations for forged hammers and processes are designed as massive block embedded in soil, large depth of soil. Purpose is to provide such dimensions of foundation so that elastic settlement is more than amplitude of its vertical vibration. Design values of amplitude of foundation vibrations under hammers are chosen between 2 to 2.5 mm. Hence, the height of foundation will have to be increased considerably to obtain desired value of static state settlement. This involves extra cost, and each ton of dropping part weight requires 80 to 120 tons of foundation weight. Hence, these days, foundations under hammers are designed to blocks or slabs loaded from above by backfill in such ratio between weight of foundation and that of dropping part is about 40. Nowadays, foundations under forged hammers are designed by method of single block foundation for anvil and frame. By this method, tilting of anvil with respect to frame can be prevented. Pads under anvil are also given. Pads under anvil are also given, which are made of square timber of size 10 into 10 centimeters to 20 into 20 centimeters. Timbers are laid flat in one or several rows, one over another one. Each row is braced for transverse bolts and forms a separate mat. Pad must be rigid and mat should be strictly horizontal. Smoothly planed and easily fitted into excavation. Fitted into excavation. Timber should be impregnated with wood preservative for preventing its decay. Space between pad and excavation. Timbers are laid flat in one or several rows, one or other. Each row is braced by transverse bolts and forms a separate mat. Pad must be rigid and mat should be strictly horizontal, smoothly planned and easily fitted into excavation. Timber should be impregnated with wood preservative for preventing its decay. Space between pad and excavation walls should be filled with petroleum asphalt in order to prevent horizontal displacement of anvil along bad. 4 timbers are placed around near base. So I can say let's little repeat this. This is I repeat it fast. Nowadays foundations under force hammers are designed by method of single block foundation for anvil and frame. By this method, tilting of anvil with respect to frame can be prevented. Pads under anvil are also given, which are made of square timbers. Pads under anvil are also given, which are made of square timbers of size 10 into 10 and 20 into 20 centimeters. Timbers are laid flat to one and several rows, one over other. Each row is braced for temperature transverse bolts and forms in separate mats. Pad must be rigid and mat should be strictly horizontal. Smoothly planned and easily fitted into excavation. Timber should be impregnated with wood preservative for prevention of decay. Space between pad and excavation walls should be filled with petroleum asphalt in order to prevent horizontal displacement of anvil along land. Bad 4 timbers are placed around a smooth base. Now, the steps while designing foundations under reciprocating machines. Let's say that there are some steps, we study them, then we have to see about what is soil in this soil data and then seismic methods of investigation, and of course then resonance method, certain codal provisions, and then we'll see my dear, let's now talk of machines foundations. So let's do steps while designing foundation and some machines. Let's watch that. What we should say, I think space is required. Yes, no, it's not. It will go away. So I take it. I can't keep on laptop and it touches. By chance it touched this system. What's this? These are people sending long messages. I'm very fed up with these people. They are just disturbing for nothing. What it says, I can't even read this message. Matthew, Alexander, Abraham. Good afternoon, dear. What I do with this? Good afternoon, dear. Good morning, very calming, dear. What it says? Thanks. Thanks, dear. Now it's that steps while designing foundation and replicating machines. What are the five? Let me read this page and I'll go there. Let's put here better. It is that data regarding machine must be available. That's number one. Whatever is data about machine, you must have that one. Horsepower operate in this data is given. What's required is actually say operational frequency of machine. That's okay. Operational frequency of machine, then horsepower of machine, a frequency horsepower of machine, that's called bhp, character, magnitude and point of application of dynamic loads which develop during operation of machines. Character, magnitude and point of application of dynamic loads which will develop during operation of machine. And distribution of static load imposed by machine over surface of foundation. And distribution of static load imposed by machine over surface of foundation. Shape and size of engine supporting line. And then you can say location, openings, grooves, etc. to be provided in foundation, of course. And then you can say soil data. Number two is soil data must be obtained. Soil data must be obtained. Soil data, that is bearing capacity and other characteristics of soil. Position of water table, in situ hydrodynamic of house. Then we'll say in situ dynamics of industrial swell, position of water table. And then we say design a massive block foundation for reciprocating machine with grooves, etc. or another goals. After that, columns coincide with center of gravity are I can say hey some headache. So point side center of gravity of foundation and machine with center of foundation area in contact with soil. This shall ensure uniform settlement of foundation. Eccentricity, if whatever is there, should not be allowed 69% of allowed. Eccentricity is whatever it was there. And then you can say coincide center of gravity of foundation and machine with center of foundation area in contact with soil. This will ensure uniform settlement. So we can say now we have done that. This will ensure uniform settlement of foundation, and eccentricity of whatever should not exceed 5% of base. You can see least width. Okay, say now go further. Eccentricity of, if any, should not exceed 5% of base. Then calculation static pressure on soil due to there is a calculation of static pressure on soil due to dead weight of machine foundation block. And calculate natural frequency. Calculate static pressure on soil due to dead weight of machine foundation block, and calculate static pressure on soil, and then calculate natural frequency of foundation soil system, and then calculate amplitude of now you go to calculate static pressure, and then calculate natural frequency, and then calculate amplitude of vibration of foundation soil system, and then structural design will be done using concrete upgrade M200. For satisfactory design, you can say provide rigidity and stability of machine, there should be no resonance for this ratio of operating frequency to natural frequency. Then we have to see that structural design will be done using concrete or grade whatever. For satisfactory design, following criteria must be fulfilled. Let's see what is that. What is the criteria? Following criteria? Well, I think it's wait a minute. Some headache is there. Why I don't know. Actually, I stepped in my sleep these days. The gas is there. Everywhere there's gas. Come on now, I do advanced one now says that that is we have to get foundation design should foundation design should provide rigidity and stability of machine to there should be no resonance that we know for this ratio of operating frequency and that is the natural frequency of foundation soil system should be kept under 0.9. There should be no resonance for this ratio of operating frequency to natural frequency of foundation soil system. So it says that there should be no resonance for this ratio of operating frequency to natural frequency of foundation soil system should be kept either 0.5 or between 1.5 and 2. Amplitude of vibration then we can say these are basics of the science. Amplitude of vibration should be within this harmonic and there should preferably be no air gap between foundation of an unbalanced machine and adjoining structure. You can say now steps while designing foundation under centrifugal machine data we should have, then soil data we should have, use frame, we say machine data, soil data, use frame foundation or oops. So we say, so all other steps are same, we have to move further. When I read this, I find out is a problem. So let's now move for this. After such way, we have to put some water, solves the problem. So now it states that steps while designing foundation for machine producing impact such as hammer. Machine data we need in that we need nominal weight of dropping part. In drop hammer, real weight of dropping part includes upper half of die in addition to weight of ram. Piston and rod, hence in these hammers real weight of dropping part is greater than nominal weight. Weight of anvil and dimension of base area. Weight of hammer including side, frames, ram, cylinder, etc. but excluding anvil weight. When anvil weight is not available, it's permissible to assume anvil weight to 15 to 20 times weight of arm and total weight of hammer, and may be taken to 25 to 30 times weight of arm, weight of ram. So it is 15 to 20 times weight of ram and total weight of hammer, and then we may be taken as 25 to 30 times weight of ram. Maximum weight of ram drop, upper piston area, average working pressure of piston, diameter, position and length of anchor bolt, thickness of pad under anvil, the location of hammer, in shop with respect to adjacent foundations, under engines, machinery and other buildings, etc. and depths of these foundations. This is machine data. Very long one. You have to know complete data before doing something. Now soil data. Same as other machines, design in foundation under hammer as blocks or slabs loaded from above by backfill. See, gas is coming out. See, when I press my mouth, the gas is there, I dissipate that. I try to dissipate and then it comes out and I feel relief. See, I'm feeling relief by doing that. You see this? I'm just rubbing, just you can say kind of self massage, dry massage. Here, see, gas is filled in here. That's all. Gas comes out. I feel relief. That is. You see how it's happening. This happens with me generally. Because the gas is coming out. This is also in engineering, I can see. This such type gases, such type of gases are trapped by building. You see, which comes out. Just means something extraordinary, I am telling you. This happens to me generally. See. Maybe it's nothing to do with engineering, but I am connecting it to engineering. Either it's coming some imbalance of gas. Some imbalance is coming out. See, as much as I massage, I feel better. Then gas is out. See, then well, there's a dislocation of subject. So we say soil data is same, then design a foundation under hammers, blocks or slabs loaded from above by backfill. Ratio between weight of, we have gone through that rate of foundation and dropping parts should be 40. Thickness of pad under angle depends on weight of dropping parts and type of hammer. The thickness varies from 0.1 to 1 meter. Then calculate velocity of dropping parts at beginning of impact. Large hammers may be divided into two groups. And static force, static pressure on soil. Alright, now I was little, off mentally to do some brain problem, some headache problem. I should not say brain problem, gas problem. So we say now, so design, I have gone through that. So calculate velocity of dropping parts and beginning of impact. Large hammers may be divided into two groups, those with unrestricted drop of our ram and those with restricted ram movement. Determine weight of foundation and its area of contact with soil by restricting amplitude of vibration and static pressure on soil. This is the preliminary design of foundation, preliminary size of foundation. Design actual foundation from data obtained above, and dynamic analysis of foundation may be done. Structural design should be done in compliance to IS code 2974. In situ dynamic investigation of soil. In situ dynamic investigation of soil. Subsoil investigation is always done to find out properties of soil under static loading. Besides this dynamic investigation of soils, test should be, in situ test should also be done for proper design of foundations subject to dynamic loads, elastic constants of soil, damping coefficient of soil, this elastic constant of soil, you can say damping coefficient of soil, natural frequency, etc. are determined by in situ dynamic investigation of soil. There are two methods which are used for dynamic investigation of soil and site, and these are: number one, seismic method, and number two, steady state vibration technique. There are two methods, you can say resonance method and wave velocity method, that is for steady state vibration technique, resonance method. Well, for dynamic investigation of soil, let me put it here, it's very difficult here. For dynamic investigation of soil, यार ये जाओ ना यार, क्यों बेकार तंग करते हैं लोग यार, काम अगर कम करते हैं। That is, for dynamic investigation of soils, two equipments are necessary. That is, first, vibration generating equipment, and secondly, vibration measurement equipment. So, you may say, let me go for 2 minutes, I think it's impossible, I don't know. For dynamic investigation of soil, two equipments are necessary, and that is, firstly, vibration generating equipment, and secondly, vibration measuring equipment. In case of seismic method, source of impulsive energy may be explosive charge or hammer slap against ground. further, in case of seasonal method, source of impulsive energy may be explosive charge or hammer struck against ground. In case of steady state vibration technique, you can say then, say in case of seismic method, source of impulsive energy may be explosive charge or then in case of steady state vibration technique or electromagnetic exercise can be let me just go for 1 minute, 2 minutes and come back. I think just a minute, my dear. I go and come back with your information. Go and come back and put it in. Just 1 minute or 2 minutes. So back to you again. My dear friends, sorry for that. Now, so it's here. Let's do that. So what is said that soil investigation we're talking of soils. So dynamic soil investigation we're talking. So for dynamic investigation of soils, two equipments are necessary. First, a vibration generating equipment, and secondly, vibration resonant vibration measuring equipment. In case of seismic method of source of impulsive energy may be explosive charge or hammer struck against ground. In case of steady state vibration technique or an electromagnetic exciter can be used, whose rate of frequency may vary from 300 to 10,000 cycles per second. A rotating mass mechanical oscillator having a frequency range between 0 to 100 cycles per second can be used. Now for measurement of vibration, normally velocity or acceleration transducers, as these are small in size and rugged in nature. Signals picked up by transducers are fed to dual beams oscilloscope. Signal picked up by transducers are fed to dual beam oscilloscope. Vibration meter can also be used for recording of accelerations. I repeat, this paragraph I repeat whole. This is some technical paragraph, and this is for dynamic investigation of soils. There are two equipments. What is called vibration generating equipment, and other one is measurement equipment. Seismic method, in this impulsive energy source may be explosive charge. We can use explosive charge or hammer, and that's struck against the ground. In case of steady state vibration technique or an electromagnetic exciter can be used, whose rate of frequency may vary from 300 to 10,000 cycles per second. A rotating mass mechanical oscillator having a frequency range between 10 to 100 cycles per second can be used. For measurement of vibration, normally velocity or acceleration transducers, as these are small in size and rugged in nature. Signals picked up by transducers are fed to dual beam oscilloscope. Vibration meter can also be used for recording acceleration. Now, seismic method of investigation. This method is based on assumption that soil fulfills all conditions of an elastic body. Naturally, some disturbance or sudden shock at whatever point on elastic half space will cause elastic waves to be propagated. The three elastic waves are propagated, we know well, which are of interest to soil engineer. Compressional wave, that is P wave, in which particle motion is a push-pull motion parallel to line of propagation. Then S wave, that is shear wave, in which motion of particle is at right angle to direction of propagation, and relay wave, in which particles motion is made up of both horizontal and vertical components. P and S waves are called body waves and propagate radially outwards from a source located on source along a hemispherical rail front. Relay waves propagate radially outwards from source along a cylindrical wave front. So body waves is propagate radially outwards from a source located on source along a hemispherical wave. Now in seismic method, impact is given at selected reference. Impact is given at selected reference point on surface of soil, which are called impact station by hammer, and time of arrival of first seismic wave from along a line at different points are picked up by geophones or other suitable transducers. After this, these are fed to a storage type oscilloscope, which keeps a continuous record of arriving seismic waves. Amount of shear produced by such an impact on soil medium is small compared to change of volume. Hence, most easily distinguishable arrival is that P wave which has highest speed of travel. Velocity of S wave is slower than P wave and shall not be noticeable on oscilloscope. This difficulty can be overcome if shear type of disturbance is caused at impact station. Arrival of a stable relay waves are easily distinguishable if two geophones are used simultaneously at every recording station. One phone will measure vertical displacement and other will measure horizontal displacement. Resonance method. This was the seismic method, now resonance method. You can say seismic method of investigation we did, and in this we are going to do resonance method, and that is wave velocity method. A resonance method. In this method, a pit of suitable size 6 meters by 2 meters is dug or excavated whose depth is equal to depth of actual foundation. A cement concrete block of suitable size is cast in units in situ, is cast in situ. A cement concrete block of suitable size is cast in situ, say 1.6 by 0.9 by 7.75 meter, and cured for at least 15 days. Oscillator is then mounted firmly on block. Oscillator is given a variable belt drive in suitable frequency range, resonant frequency. So this block we construct and cure, then oscillator is given, you can say oscillator is then mounted firmly on block. Oscillator is given a variable belt drive in suitable frequency range, that is resonant frequency must be reached. Transducers fixed on block pick up vibration and you can say signal after the amplification is indicated on vibration meter. Response curve can be drawn by noting amplitudes of vibration at different frequencies. A typical response curve is shown. Frequency has been plotted on x-axis and amplitude on y-axis, and amplitude on y-axis from natural frequency. From natural frequency, soil Now we go further on this, and from this natural frequency, soil constant and damping properties of soil can be determined. So this is frequency on x-axis and amplitude on y-axis. So we can see Fy and Fz, 1 and 2. Recovery response curve for horizontal resonance. We can see up to 2000, let us say, and we can show you this here. This is what is shown here. You can read this. This is very new. Now we go further on this wave velocity method. Wave velocity method. In this method, dynamic properties are determined by measuring R wave velocity. R wave velocity, that is, dynamic properties are determined by measuring R wave velocity. In this case, ground is excited by means of an oscillator for giving harmonic vibration. Wavelength of resulting surfaces wavelength of resulting surfaces waves between points that are vibrating or in phase with vibrating source is then determined. Wavelength. This can be done by measuring distance between two velocity pickups. When two phases of two vertical amplitude channels of a double beam oscilloscope are made equal, wave velocity can be calculated from known frequency and wavelength. After calculating wave velocity, shear modulus, and dynamic modulus of elasticity can be determined. This method has a drawback that it leads to erroneous measurements if there is water table. That is, water table converts soil mass in layered system. Wave velocity method is not affected by presence of water. In resonance method, some difficulty is experienced when it becomes impossible to obtain a proper resonance curve. Method can be used for in situ dynamic investigation of soil depends upon availability of equipment and site condition. Indian Standard Code for Practice for Design of Foundation for Reciprocating Machines. Let us see what our country says. This is one method. It's of course not very complicated, but I'll see that one, how it works. That is Indian method for practice for design of foundations. And let us see what it speaks. This IS code of practice 2974, IS 2974 part 1 gives following criteria for design. Size of foundation block in plant should be larger than bed plate of machine with a minimum allowed clearance of at least 15 centimeter. It should be 30 rather, if it is less. Width of foundation should be at least equal to distance of center of gravity of crankshaft to bottom of foundation in all vertical machines. Width of footing should be at least equal to distance of center of gravity of crankshaft to bottom of foundation in all vertical machines. Then depth of foundation should be such as to reset foundation, rest foundation on a good bearing strata. Depth of foundation should be such as to rest foundation on good bearing strata and to ensure stability against rotation in vertical plane and to ensure stability against rotation in a vertical plane. Combined center of gravity of machine and foundation block should be as much below, that is combined center of gravity of machine and of foundation block should be as much below top of foundation as possible. Wherever possible, operating frequency should be lower. Operating frequency should be lower than natural frequency. Wherever possible, operating frequency should be lower than natural frequency of foundation soil system, and frequency ratio should be less than 0.5. When operating frequency is higher than natural frequency of foundation soil system of machines, frequency ratio should be more than 2 for imported machines and more than 1.5 for other machines. Now what is natural frequency? We studied before. Natural frequency in cycles per second can be given by following formula under given stress intensity, and that is Fn is equal to 15.8 over under root delta, where delta is equal to elastic deflection of foundation in millimeters with respect to entire area of foundation. Elastic deflection of foundation in mm with respect to entire area of foundation. Its value can be determined from this curve, and that is deflection in mm, that is 0, 1, 2, 3, 4, 5 by 10 is deflection, and deflection in mm is a delta, and then bearing pressure in 100 kg per square meter. 100 kg per square meter. Okay, that is bearing pressure is 0 to 280 kg per square meter. Alright, then number one curve is gravel, then it is dry, hard clay, then wet clay and sand clay. We take case of gravel where deflection is very little, but bearing pressure is high. In dry hard clay, you can say deflection is in dry hard clay, deflection is also deflection increases, and in same way as bearing pressure increases. In wet clay, again deflection is much more than pressure, and sand clay is down to down. Yes. So permissible bearing pressure is when you go, let me show you first this sketch and these two curves. I think curves are already shown. I'll show this sketch, that is how to find this only. This is a deflection on x-axis and pressure on y-axis, and these are four curves here. You can see number one, number two, number three, number four, four curves. Downmost is clay, then is wet clay, you can see. Number one is gravel, and other two like that. You can see deflection moves on to the right side, that's on the right side. See it? You can see that. You can move further, and you can see that permissible bearing pressure for under dynamic load may be taken 1/3 or 1/4 of permissible bearing pressure under static load. 1/3 or 1/4 of permissible bearing pressure under static loads. So what we say now is that amplitude of vibration, permissible amplitude should not exceed limiting amplitude. So you can say permissible amplitude should not exceed limiting amplitude for machines prescribed by manufacturer. Then we can say that Permissible amplitude should not exceed limiting amplitude for machines prescribed by manufacturers. When such data are not available, we say that again, permissible amplitude should not exceed limiting value. Limiting amplitude for machines prescribed by manufacturers where such data are not available for preliminary designs and for relatively unimportant structures. Limiting amplitude may be determined from curves which are here. These are curves now. This is called frequency in CPM, and then lighting amplifier. So this is a probable amplitude on mm of machine at operating frequency. Now this is, I show you first curve which are having in that 1, 2, 3, 4, 5, 6, 7, 8, 9, the 9 curves. For example, one is on frequency that is not so we'll see now how it works. And this is probable amplitude. In this curve, let me show you first curve, what curve is about, and then we'll talk of. This is curve here, you can see. In this curve you see that probable amplitude in mm of machine at operating frequency can be determined by following formula. Az is equal to 250 f theta that is, this is formula here. You can see this formula yourself. Ws and Fx, yeah. As is equal to 250 F8y over here. Delta As is equal to 250, Ax is equal to 250 F over S. That's now. Its amplitude is equal to 250 F naught over Wy W into Fn square or F naught square. Dynamic force in kilogram. Wv is weight of machine and foundation in kilogram. Fn is the natural frequency in cycles per second, and W F2 Fe Fw. That's R, and F naught is dynamic force in kilogram, and Wv weight of machine foundation kilogram. F naught is the natural frequency of cycle, and this is all called amplitude in mm. R is called amplitude ratio. So R is equal to eta square over 1 minus eta square whole square plus 2 epsilon eta whole square. So you can say so in this eta is called the frequency ratio, eta so you can say eta is equal to frequency ratio or F for Fn, epsilon equal to damping ratio or damping factor, CO1 and Cc is giving a and this damping factor. So R is equal to eta square over under root bracket 1 minus eta square. That's one thing. This value of epsilon is we determine from dynamic gas when the value of epsilon is not really then hammer foundation having so now let's see that Indian standard code of practice for design of foundation of impact type machines. So I think we'll take it later on. So what we have learned today in this we have learned in this today about you can say we started from here, we started from foundations, means you can say frame foundations, and went through steps of designs and also designs and designing methods and which methods we adopt, seismic or steady state. Then we moved on to the pulse curve for origin to the seasons and then natural frequency as sector standard code and this down to this. We'll take it later now, we'll do something else. We'll take it later, so it says, I can say, right, so now we have to see, in talking of construction which is the real engineering, to be very frankly speaking, I consider construction to be real result rather than considering its end product, of course, but its real end product. Real one that we have to understand, and if you understand that, I think that's what we can do. Quality is involved there, it's very important point. Quality, and quality where you cannot quality of construction, quality in construction is very important to achieve, and it's not impossible that we cannot achieve it. It's not impossible. It's done. It's achieved. And there are hundreds of projects, there's thousands of projects, buildings in Gulf states, in other states where this has been achieved successfully without causing any problem. So they have patience and fast taking as well, both together. They understand quality in a systematic manner, and when system is established, I think then there should be no problem in achieving quality. Only difference is if you work haphazardly, you shall never get quality. You shall certainly spoil. You shall certainly spoil your system. I tried to achieve quality in some of my building when I was here after coming, and I could not achieve it to that extent I thought of. It's really regretful that even if you try, there are no people who understand that. People should be there to understand something, only then you can say that they work for you. There are some people who are there not ready to work for you. Then there are some people who want to learn something. If there are people who learn about construction, well, I think they can, if they are true, if they are genuine, if there are aspirations, they have aspirations. It's my given impression or somebody else given impression, that doesn't matter. Matter is that it's you. I every day talk of quality and condemn actions not taken by people, because people are not serious even in their own profession. That's a problem, that's a point where you have to, fix a cut, you have to fix some cut in a sense that we should not appreciate something that's not happening, and that's self-deceiving. If you say no, we have a quality, we do it, we do not do factors, but we don't have, in fact, we don't have that. That's also a fact. We don't have something and we say no, we have. There is no end to that. No, we have. No, we don't have. We don't have, that's true, and that's truth also. How to have it, that's a proposal, that's a position, contemporary debate, contemporary consideration. For that, I can only give my examples, how struggle they have to do, what level of struggle they have to do to get quality. And I explained last time, yesterday I think, about one diesel generator foundation. That was long back in 84, 83. This was interesting, of course, because everything was manual and we were successful in doing that. And that because there were no inspectors, nothing, we are only inspectors, we are engineers, we are consultants, and we of course we are not designers. Design part came from France, and we got detailed methods in sketch form from them. We did not find any English language because French does not use English or did not use English in those days, and there were many languages used by them. So they could not even explain to us what was right code, but they tried local, also our own country people to translate that information, because it was something that like that could happen, and they go on like this today, this and very good. That's not going to work forever. Until we establish our systems and stick to them, When I say system, I do not mean to say codes. No, I'm not saying codes. I'm saying working methodology for every item we have. We have. I did same thing in another project that was in Ruiz in 2003. Almost 2000, 2001. I joined that project in Madras and Ireland. And I learned a lot from the way I also learned. I know these people who say I know. They will know. So I was saying about construction issue. Construction which is actually very, very intellectual and hard work both. It's physical work as well as an application of mind. Application of mind of construction is very much original. There's no copying and paste. Hard work for working. Even if somebody claims I work for structure and earlier, suggested. I told them this is now quality work you have to do. No rush, quality work. What we do, if there is something, so we have 500 cubic meters concrete for that foundation, and that is massive block. Massive block. No. It is wonderful in case quantity is concerned and fast work is concerned. That's wonderful. I don't mind that. And that was not just massive block. It was one of unit that was in an area of control mechanism of corrosion protection. Corrosion protection, which means that you have to keep steel reinforcement safe within concrete itself, and you have to, if there's some corrosion within, you have to capture all those oxidization through anodes from centralized unit, and anodes and which are connected through reinforcing parts to steel. This one project, that was facilities project. This was ethylene project, which is 600 kTA. This is 600. You can say 600,000 tons, 600 kg, I am saying 6,000 K stands for 1000 tons per annum. 600,000 tons per annum plant, ethylene plant, ethylene cracking plant. It's wonderful. Means if you see category of its mega plant, are more than 100,000 cubic contents of RCC structural concrete itself, other than those of non-structural concrete. So when such a plant, you have to see, you have to understand that plant first, geology first. That's also very important criteria we have to understand. And if we can do that, we can do wonders of that. And if you do not understand reality, we can just say, okay, I will do that without understanding. When I'm talking of Catholic protection, this means steel is very new, newly purchased, like us. So what was provisions? That's to understand first of all what was provision in those plants and process area, that was not ordinary area, process area, which we can say you have to be very critical involvement in that, because this comes under view of blast area, blast area, that's you can say where there are possibilities of blast and a movement. So you can say that process, your area must be having certain designs to contain blast, and also that it should keep performing simultaneously. So this cathodic protection, which name, which absorbs all elements. When you fix the throws, anodes, I mean, so not nodes, anode on main foundations as well as on columns in such a way that they are connected together, not remaining disconnected, connected together to each bar of foundation. Each bar, I'm saying each main bar, and then further next bar, next, that is connected to, all connected to their control room. A room controls whole planet. You have to train those people to come to tracks and not to stay away from tracks. So connection of each column, each foundation through anode through anodes to cathodes at central location. That's called cathodic protection design. Cathodic protection design is even if there is oxidation due to atmospheric moisture penetration, that shall be removed through that machine or meter. There are so many examples. Means there are two types generally. One is critical and one is non-critical. When one say critical, this means there are many kind of equivalent size powers. Okay, let's say, also, other one is also here. We have to understand that very well. That point. How to understand, that's what we are discussing here. I'm not lazy, I'm just showing that I am lazy because of corrosion. I am a steel bar, I am corroded, I have been debonded from concrete, so I am dancing in concrete like this, which means I am not connected to concrete, I am isolated from concrete. That's what I am saying. Corrosion. Corrosion isolates itself from concrete, or you can say it loses its strength, for which purpose it still is potent. So there are, you can say, there are generally, you can say, two methods used for this. Many more we have. I learned about two only. So I will discuss only those two, not all, because I shall discuss only those two methods, and those methods here are, I can say, little stop me for 3 minutes, and these are, individual footings and like this I say big foundation or massive block. This is a critical type arrangement in massive block and non-critical in individual footings, but it is everywhere. Non-critical is very easy. It is a boss only, boss. This boss is connected to some, you can say, some place, a height at some height in column foundation, or you can say in stub area, and then when circuit comes in, it will connect it. That's just called, it's just called the boss. We call that, and boss is fixed in there in some place of column, so that remains embedded in concrete, and wire goes out and shall be connected to system later on, network of wire. Then it is, other one is critical, where C clamps are the wire is there, and C clamp is taken to last part of steel, end of steel. That possibility you have to understand. That possibility you have to understand, you know what I mean. Every single bar we say start here, you put this single clamp here, and all these bars are connected in like this, all this, and comes and go down and again come back up and complete circle, and then go to cathode, anode. anode that you put in there. Anode is a standard, that's a recipient of all that is fixed into that. How many, whatever number of experiments you do, yes, the criteria of a quantity that's like that. So this C clamping arrangement, and then we have to see not only arrangement, it is to be ensured that once arrangement is done and that and control anode is fixed in at design locations in foundation, whatever is fixed to foundation, welded there, and then in this system of external controls, they said your process controls shall be external. So when we say cathodic protection, we have provided in critical states, we have to make sure it is working. How to make sure? That make sure is test of connectivity, that these are connected together, these are acting together, and that is voltage check. You see dial checking of that voltage, and if voltage is continuous, this is connected one, and that means it will work in future. So we have to allow it in concrete embedment, and it remains in concrete. That's additional part which I should tell about this corrosion. It's called corrosion control, and it's done only on steel bar surfaces. It cannot be done in coated bars. When I say epoxy coated bars, on those this is not permissible because it won't allow whole current to move in. It will allow some part current of full current to move in, so that probably where we are using cathodic protection item, we should not interfere with this, and it should be without coating steel. So that is one part of technology, because corrosion cannot be allowed on the steel, and if it's allowed means it will take your steel to deterioration, decay, and it will erode. One day you will find it does not work and it rebounds from concrete, and then purpose of steel is practically over. So we have to see whether we want to practically over this or we have to do something with that. It's very important criteria we have to understand. Alright? So now, what I have to understand that question is, here question of quality we are talking, that quality is also important. When I am saying quality, it doesn't mean quality control only. This means quality in a way it should be declared that it's quality. It's not simply test, means it's simply satisfaction. Satisfaction, that not customer satisfaction alone, engineer satisfaction itself. Engineer if not satisfied, if engineer is not satisfied, I can say you can't sleep, believe me. Your conscience shall not allow you to sleep. If you are a real engineer, if you are engineer only to take salary and sleep, I'm not talking for those engineers. Engineer is a commitment. Engineer is a profession. Engineer means you do something for someone to make that person's life better. This means you have been that nature, power, whoever you understand is, you supporting him, you are keeping him free of tension. When you take charge of everything honestly and doing that. That's very important part we have to really understand. We cannot say that it is done or it's not done. Everything is done in its way. So my part is procedure of concrete, how it was done when we did massive block, of that, built that big foundation. That is, I had some sketches I showed many times before also, but it happens that we don't remember everything every time. We lose something and again we have to repeat. And repetition doesn't cost, but it gives perfect answer that we may say that if we can do that now. We see it's a claim. This is from chart 935 monthly expenses policy. So it's not that. Yeah, in this I would like to show. Yes, I forgot that. Again, in this royal charters there I have to show that, because we talked of royal charter of institution of engineers and I did not show it. I should have shown to you. But no problem, I'll show it now. Which means, let us see first of all what it is. It's this one. It's very small, but I'll show you this. I'll show you this blown up. This royal charter. So let me see, it's blown up. And sorry, it's this way. Oh no, only fast. It is this body I'm talking of. Maybe it's not turning, so I take this way. It's not turning up, so I should take this way. Yes, turned up, so it's okay. Stand up. My God, what is this doing? You're not following me. Why are you doing nonsense? Yeah, I should turn up. Why it's not turning up? I don't know why. Why are you playing with me? What happened? Disappear? Why? Tension? You are in tension. You are in tension, my dear. If you are in tension, it will happen to me. Is that? Oh, again it don't. Oh, I think my hand is on this. That's the problem. Oh my God, this telephone technology. My hand goes on to that, like that's this, It's happened. Oh, again you are there. I don't understand, you bloody fool. Don't understand your. I don't understand this. This is that. This is Institution of Engineers World Charter. And this is Institution of Engineers. I just draw it back. It's not getting fine. Maybe like this. Let's say Institution of Engineers World Charter. I just read the glyphs on this, so just for information, it's written that Institution of Engineers India, Royal Charter, Act, Court of Buckingham Palace, and this is present King's Most Excellent Majesty, that is in council, whereas there was this day read at board a report of Committee of Lords of His Majesty Most Honourable Privy Council, date of year 1935 in verse. Alright, Your Majesty, having been pleased by your order of by your order of 21st day of whatever it is, February 1935, to refer on to this committee of a humble petition of Sir Thomas Uthrai Russell, President of Institution of Engineers, India, and other praying for grant of charter of incorporation to said institution. Lords of Committee, in obedience to your Majesty, said order of reference, have taken said petition into consideration and do this day agree humbly to report as their appeal options in Grund His Majesty, having taken into consideration said report and draft charter accompanying it, it was placed by and with advice of his Privy Council to approve thereof and to order, as it is hereby ordered, that most Honorable Marquis of Zealand, one of His Majesty, in first principle, Secretary of State, a due cause, a warrant to be prepared for his message. So it's that one which you can read yourself. This is just cover page. There are 22 documents in this. I'm not showing you. I'll show you later on. But I talk about that on share. That one. Screen share, I'll look for that if possible. So I move to what I was talking about, machine foundation, which is time now we have to. So I have to see, yes, this document was, let me see which is that one. It's here or there somewhere else, I don't know. Credit and this and that. Also Sunday. This is monthly expenses which are a global fair. Oh no, don't disturb yaar, come on. तो ज़्यादा बहुत जल्दी खुलता है हरियाणा में. यार क्या होता है इसको? बनता ही नहीं है. So I take a card. Let us say what is there it is. Makes sense now. Very good. Music follow this music. Documents. Where is that? There was a program file. Oh, yeah, why are you coming every time? New folder, new folder, new folder. पता नहीं क्यों यार क्या करता है. System that that's the end of this index. But statement. charter is also there. I'll just give a glimpse of this charter also. Better, a glimpse of this charter. Maybe it is here. Oh yes, let us see something about here. Just like a glimpse of that. Abhyantrik Kram. Let's go further on this. This is notings or notings, so I can't show you that. Exactly, there are some additionals here which will not be any meaning. So we'll show you later on now because it is different. I cannot show that one here. I'm trying to find my file which I'm not able to immediately locate where it is. You know, when you need something you can't get it, that's another problem. I got it. Draft concrete, sketch base, mass block concrete and method statement sketch admission building. So mass block, let us see. Mass block. Yes, I got it. I'll show you this. Okay. What I am showing is trying to show is I say that if you can see here is a compressor foundation I'm talking about, and that is here. You know, I'm not showing this detail, but I'm showing method how to cast this. That's important here. It is, you can see, let us say that this plan here, let us say it starts like this, and I just glue it down. Let us see this, that this is a plan here, and this is plan of this, you know, this is plan of this is plan, you get it? Plan means I have shown certain lines. Why lines are there? Because these are, you know, various steps. These are not some lines of concrete but steps. Lines are outside only, others are 1 meter. When you see width of that, it is showing how many months are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 meters wide it is. It's that width of craft, and also similarly it's lengthwise. So this is dimension only. Others, this is plan I'm showing you. Plan of a massive block footing, and how many these steps I have shown. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps are here. Probably 2 meters wide, so or maybe more. Whatever it is, doesn't matter. But this is that plan which are going to concrete in the height, and that section is also shown here. So sketch 58 massive block concrete post sequence, and if you see above our other one, it's that one, other one. It says if you see in section, these are steps. You know, you can see this 1 meter, 40 mm, and 40 centi, 40 centi, 40 centi. Let's say here 40 centi, 40 centi, 40 centi, and you know. We have how many? 1, 2, 3, 4, 5, right? There are 5, 1, 2, 3, 5 and 22 that way. So you can say 5 vertically and let's say 22 that way. So it is about 22 to 5, 5 to 10, 5 to 10, 1 to 6. So 610, sorry. This. So I'm looking at this. 110, sorry. 110 steps are there. This is section wise longitudinally I am writing out with number of these steps in this. See, try to understand what I'm saying. There are steps, horizontal steps, and this is section vertically. There are 5 layers going to be in each step, but this cannot go one time. We have given numbers of step, and these numbers of step given some sequences as well. And in this sequence, these are going to be laid. Example, if you see closely, you will find numbers in that. And then here, see, you have to position your pump accordingly. So it is, you can say what it is written. You have to see that one. It's written in this, that it's written in this. You see clearly, you can see now a big one sketch here. These are steps, and this is down one plan, water plan. And it's clearly saying that concrete truck here, you see concrete truck registration is written concrete truck. You see in a square box here, it's concrete truck written here. Concrete truck and pump location both are. I mean, so it's concrete truck and pump is there. Pump is there, this side, pump is that side. It's written here, and also how many masons, how many helpers, how many carpenters are there. This is too written here. So that's what I say, and this means if I say number of stepwise example is it's number 1, say at lower corner, it's number 1, you can say at lower corner is number 1. Number 1, then you see number 2, and then you see number 4, then number 1, number 2, number 4, number 6, and then it is number 10, number 14. All these are lower step, and if you go above 1, is number in between number 1 and 2. There is I think better number here. Yes, it is. First there should accept this one. So according to these numbers, we go. Let's again understand what I mean to say, because sometimes you don't understand. It's better to understand that. When I say numbers, let us say what I say now. In first row, if I say numbers are written in first row, and what are those numbers? You can see yourself. Number 1, then number 3, number 7, number 11, number 22. And in second one you can see number 2, I think number 2, number 5. Number 5 above that, and then number 5, number 9, number 15, number 25. And like that in next is 4, 8, 13, 19, 28. In next one is 6, 12, 18, 26, 34. And in next is 10, 16, 24, 32, 38. In next is 14, 20, 27, 36, 42. In next is 17, 23, 33, 40, 45. And then in 21, 30. 21, 13, 21, 30, 39, 44, 47, and then it's 29, 35, 41, 46, 49. Right. So these are sequence numbers of what we wanted to tell you. These are sequence numbers of steps. This is called method of pouring. We cannot simply say start and end, that's not allowed. We don't do that way. Concrete is big, it's massive block. There will be line, maybe many trucks standing, and we have to dispose it. For that we should be ready. How to start? Means we have to think sequence in such a way that transfer time of concrete from plant to site, time for slump, etc., etc. We added that one, and then we start science also this way. See, it's different kind of method. Generally, in our site language, we call it stepping. If you don't tell foreman stepping, they won't understand. And it's a method to avoid cold joints. Cold joints. Cold joints, some people understand, some people don't understand. I don't say people don't understand. Some may not understand. Cold joint is very specific term, and also with that cold joint there is flash setting, very important term. These two terminologies are very important, not visibly seen but effective. Very, very much effective for you. It's not I'm going to put it out here. I don't know what this will want to say. What they want to say. Oh, I don't know what they want to say. What is this nonsense here? Who's this? Hello? 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 You're not speaking? Hello? हेलो। सब बड़ी फुल स्पीड में नहीं कर रहा है यार, कैसे लोग हैं, मिल जाता है तो स्पीड नहीं करते हैं, क्या पागल लोग हैं यार। Full of idiots this country really. I don't know people here, what sort of people are they? I can't answer really. I forgot to scan today, no problem, I'll take it next time. It's not possible at this time. Well, I was talking about construction method statement of massive block. So this is basics I just explained. Otherwise, excavation and blinding, or before blinding, compaction or soil improvement, these are all there. You have to excavate, you have to allow access to machine into foundation if required, or excavate and come out, and then you have to see if soil improvement is required. That depends upon bearing capacity of that soil, which you have to investigate. And if it's required, you have to provide soil either stabilization or improvement in whatever way. You want stabilization, you have to do stabilization, or if you want to remove bad soil with good soil, then you can do that as well. And you have to come back. It is no need of anything, then you continue. So you compact it and test field density, and if it's 98% to standard proctor, it's okay, cannot be denied. The question here is weight of this foundation. Let's say it's 400 cubic meter concrete, and prepared for 11% of steel. So how to handle that concrete? 400 or 500 cubic meter. If you say 500 cubic meter, let us say this is about, how many tons? 2.5. 500 means 1000, and then 250. I'm sorry, 500, 125 tons it is. 500 cubic meter. 500 I'm talking. 1000. 1000 2 into 5. 25 into 5, 250. too heavy, right? 110 is 2.5, 500 is 1000, and then 0.5. So it's too much. 0.5 for 1 cubic meter. So it is 1250 tons. 1250 tons, it's going to be, let us say, in an area of 25 into 12. In that area, 12 or 1, and here's the weight of that, and then weight of machine on that, and impact. So you must have that bearing capacity first, and if it's all satisfied, then you have to do blinding, application of compaction, then you can say protection of soil, protection of concrete from soil. So you have to write waterproofing membrane or chemical isolation and water isolation membrane. That's, let's say, bitumen application without touch. That's also true. So we can say after the blinding is done, once compaction is done, test is done, and after test, and then done blinding, and then you start the waterproofing, as I said, and then protect waterproofing from some other membrane or cement mortar, and then you can start your reinforcement job on that. It should take some time, couple of days probably, because they're all heavy bars and columns have come out of that. Columns for tabletop, or you can say frame beam. This is by block and a frame above, and you have to provide, in that case of a massive block, your anodes also. And this if you like, tunnel, you go below and then you tunnel walking. It will be an open tunnel till now, until it is. So what to do now? Question is that you have done steel work, very big steel work, it's not small work, highly heavy steel in this. But in this, it's designed steel, it's not simply volume filling steel. So it's a kind of case, and it won't be very difficult to go inside into that, because you have to fix anodes, and not one anode, maybe two or maybe three. And you can circulate in and out. This is why you have need at least half meter on each side, particularly two sides, and more like that on one side. Then justify materials. So when I say that we are ready with your steel and everything, and we have done your reinforcement fabrication as well as and formwork fabrication we did. So we have to move forward, particularly there. We have to move forward, and that forward movement is for forms which are about 2 meters in height or more than that. We must take care of sides, because bolts are not in this case. You can't bolt in. Bolting is no way there, no tie bolts, it's very wide foundation. Your supporting system should be very strong all around. It should not open, because after all, this is height 2 meters, and volume is much, so we have to be careful about that. We have to install maybe steel thing, suppose. It's not simple by saying that's right working. So now let's say you have done supporting, you have clamped everything, you are tied up, and maybe you are ready. You have provided additional supports or corners, clamped by whatever method. Stronger vertical members you are using in this, stronger horizontal members you are using in this. And of course, you are not going to immediately pour it. It will take some time, particularly because in layers you have to pour it. And it will come back also to avoid cold joint. I missed again definition of cold joint and flashing, flash. So we shall speak again about that, so that you should not misunderstand. I missed one. Cold joint means during concrete result, when you pour it, you have to apply this correction, because this is a mistake if you don't apply. And this was a terrible mistake. We can say it's not ordinary mistake, it's a terrible mistake, incorrect mistake. If you produce cold joints, there is no way that you can correct it. It's a really very, very, gruesome for concrete. We destroy concrete actually by not understanding how to avoid cold joint. Generally, engineers sometimes ignore, and that results in bad concrete. Cold joints and flash setting, these are very adverse producing. This producing very adverse results when we do not care for them. When I say cold joint, it means this one patch of concrete you laid in after getting, and this concrete shall start setting in after some time. So what is time left for setting, you have to understand. It's already that was in mixer, and how much it has started or not started setting. You are laying it, then what time is left for that start setting, and when you get next batch, this is this relation that you have to understand. And if you understand that relation, then you can solve this problem. Otherwise, you cannot solve this problem anytime. Maybe you have half an hour left, maybe you have 20 minutes left, maybe 10 minutes left, who knows? You did not check that. But, before it starts setting in, when it starts setting in means it's not green, it's not hot. It's not hot, it's cold, it gets cold. And that's what we say, when it is hot, coming out of mixer, it's hot, and you can see temperature of that. And when you lay one part, then you wait for another one at that time. It should be hot when it receives another batch. Both, of course, not same, but hot, not cold. so that they can react together. But if one gets cold, that's called cold joint. Cold joint means structural defect. Structural defect in a sense, one part of concrete that is laid one, and it starts setting in, while new part which is laid on that setting in, means this is not, you can say, uniform concrete production. This you can say is heterogeneous. This cold joint means this will not be uniform through time. It's not called monolithic and uniform concrete. We have to be very careful about this. So next bits on that must be laid before cold joint action starts in. That is purpose of cold joint. And that is why we keep it in layers. We bring back second one on that, following one back before cold joint is not started, doesn't start. Other one is flash setting, which is also much more defective if allowed. Generally in hot weather conditions, I'm not talking of cold conditions, hot weather conditions when you can say that temperature is 40 degrees or steel is much more hotter, much more hot than that temperature. You can't even touch steel if it's hot without wearing gloves, gloves. In that case what happens? See, temperature of steel is more than 16, 80, 15, 80 and your concrete is 30 or less, because you can't pour in temperature more than 32, and of course there may be chilled water in your concrete because of high temperature. So concrete is, there's a temperature difference, you know, say between concrete and steel, which will vary between like 15 to 20 degrees Celsius. So you can say if your cold, low temperature concrete comes in contact with high temperature surface of steel, there shall be setback to concrete. Setback to steel is not possible, but to concrete is possible. Just like it is you're cold and it is something hot, what happens to you, you know it very well. Same thing happens to concrete. Nothing will go from steel, but concrete shall break at that point, or it will shock like you put some hot your finger in. So your finger of concrete shall result in some problem. Your finger shall result in some problem, certainly, and that is called flash. You know, there is a flash is created because of difference of temperature. This flash is very, very dangerous, and it can damage your concrete. It can set your concrete with flash that can damage concrete wet structure. It can damage, it may not segregate but damage. It can redistribute into that portion it comes in contact. So there are hundreds of steel members in concrete, reinforcement members, not 100. So at every point it happens in longitudinal cross, and what shall be your structure of laid concrete, you can imagine. Wherever steel is there shall be impact. There is a continuation of impact and it will not help concrete. That's called flash setting. So there are 2 points, one is flash setting and one is cold joint. You have to avoid them, and this is very important factor, because you are doing something for long term. Of course you are applying corrosion protection, that's something else. Means if initially you destroy your concrete by such action, certainly your internal structure of concrete is defective. You will get strength that's from cubes, not from this. Here there is every chance of moisture entry. There can be destabilization of structure. There can be movement of this liquid from one location to other location. So I call it cement water paste. though it's GGBS response, whatever it is, means flash setting requires to be avoided because your concrete is mixed with GGBS as ground granulated blast furnace slag, which is low setting, low shrinkage compound. This is low shrinkage concrete you are going to use it, and low shrinkage means it cannot accept heat immediately. That's called low shrinkage. Means it for crack formations are required to be avoided, and when suddenly flash applies onto concrete, you know how many cracks could occur there, how many millions of cracks, minor cracks could develop in those places where cold, where flash setting comes in. So purpose of your GGBS application also is defeated. This point you have to understand. It's very important point. And sometimes we cannot understand something like that, and that harms our concrete. So concrete technology is very different, and it's not only this flash setting and cold wave. These points apply here. There are more points applied, even though we are doing in sequence, that is our step, as I discussed with you and showed to you, 1, 2 up to all, alternatively here, then there, then here, then there. That's okay, analytically and for understanding purpose, and we can implement that too on site. But is that enough? Point is that. What additional common sense requires? That point you have to understand. Because this is big foundation and there are chances of break formation, everything in there. It doesn't work. This is our professional way. So what's that? We have to do more on that. Means temperature, temperature, world temperatures of concrete surface, temperatures of internal concrete contents, temperature of weather, like that temperature of, if there is no temperature. Temperature is everywhere. Those who do not understand this, they cannot understand this. But temperature effect is there. What should be temperature of concrete surface, top, sides? What should be concrete temperature once body is worked upon like hands to how to go, how this goes. So there is a specification which says that temperature gradient should be avoided. Means excessive temperature gradient should be avoided. If you think common sense wise, you are doing concrete, you have done it, heat generation starts in internal part, but should be temperature, which you can't see. It should be external part, but should be temperature. So differential thermometers we apply, they are rising and falling, that's all. We put in those into concrete portions. Such as that. Put there, they are need to be the right. So it's just so there should be controls on temperature, and for that we can provide differential thermometers while casting concrete in layers. These thermometers go into concrete in different layers, and we can read those temperatures while outside. What is surface temperature on top, what is side temperature, what is layer temperature, that we note, and this should be within certain limits. Even though we are applying thermal theorem, if application of both this cannot come in control, this means there is a problem in our technology. We should modify something, and when we do concrete like this, it's called strips or scabs. It's continuous concrete, you cannot stop that, and whatever is further required to be crossed immediately, you require to cross immediately. So that's very important point you have to learn in this method. This method is very important, and because there's no beam, no column in this, it's very fast concrete, and once you start, you have to end it. And of course, because this is different type of work, we should also be ready for one stop and in case. In case there is a breakdown, then you can't handle this concrete, because this is even in the steps, you can't make construction joints, not easy. So you should have somewhere leave those joints, at least 2 or 3 joints fully mastered and put here, and you will do this. That's why I say that there's something in this we call members, it's a massive block hole, and there are so many. You must write total method statement of this. How shall you do? How shall you start? What are quantities of materials? How many persons, skilled crew you will use? How many cubic meter concrete, and how many mixers? What's frequency you can deliver in each one, and what's purpose of method of pouring. Means all that was done into. Then you must, if possible, sketch to show position of pumps, position number 1, position number 2, or wherever possible, and also your input from contractor or documents, whatever is there, you have to understand in a way. Otherwise, you cannot say you do this things. It's professional work and must be procured by professionally, done by professionally. Your documents shall be remembered forever. Your scope one, its corrective one is in line to do. This method is not very easy. It's very important method. How to pour. I have actually installed heavy engineering. In fact, heavy construction we call it, not light construction. And because it's heavy construction, it takes time. It's not easy. You have to think a lot on this because it's a money question. You have to think everything. And if you think that something is not working, then you immediately change method after discussing it. So we now come to, after we can say, after talking of this method statement of this big foundation. And one more point I want to discuss here, that's regarding corrosion. Because corrosion is very common in enforcement, and people do not bother. In my country, India, Bharat, I don't find any seriousness on this issue. I don't know reason behind that. Only I can say that engineers are careless. You go to every site, private or government, go and see how there is no way, there is no one to look after how to keep safe still. There is no one to look after that. Unfortunately, no one to look after that. I don't like this. Why we do not understand value and involvement of steel in concrete. Purpose of steel, if you defeat in beginning, how shall it work? If you are using rusted steel, corroded steel, means already is rusted, means corrosion has started, and you are going to use same without even sandblasting or grit blasting that. You are just going to use same, not even removing loose steel. So I don't understand how you people are or how you people are professionally doing this. You cannot protect the steel from corrosion or impact of or ingress of moisture into its body. Means you are allowing water into steel, and already there are chemicals. It's called carbon steel. Carbon steel. As you must know, when you say steel, yielded steel, high yield steel, or whatever, it's all carbon steel. There are carbon percentage in that. So you are giving water to those carbon particles. This means carbon dioxide is going to form within steel structure. That carbon dioxide is solid there, and you know what carbon dioxide does. So that's what I'm saying. Don't take it easy, and better see both sides. And you have to be serious. It's not very difficult. And if you cannot do that, then there's a solution for that. Alternatives. Don't use this steel. Better use epoxy coated steel. I think there's no other way out. If you cannot protect it, if you cannot store it properly, you cannot polythene cover on this on site as well as in the store. You just throw it on soil or on water and rain, or even in the shed moisture gives in. You cannot provide coverage, polythene coverage every day, and you cannot provide polythene coverage on your site where you place it. So you are not doing good job, you can say, as far as this is concerned. This polythene sheet always only on site when you don't care, you just spoil it. And I really sometimes very angry. I become very angry. Even I used same many hundreds. So my only suggestion is that quality improvement is required for sake of future of steel and therefore future of our system. Just getting job is not an answer. So I think people should realize what I'm saying. Don't allow any dialogue. So that was method statement of a massive block construction, concrete construction, and it is really, you should not say serious, I should not say that, but it's a pending one. It's to be done. I am lucky that I did it. Really, I feel fortunate that I learned it, and not only learned it, I did it with improvement of curing. I applied thermal curing there, which is a kind of standard management of curing, where curing is done by something, not by water, by something which you cannot understand. Purpose of curing, that cement and water react together. That's right. These two compounds, water and cement, mix together, react together, and they produce heat. And because that heat is produced, this heat boils water, we put in concrete, and the evaporation happens. And that evaporation happens means we have to then think of loss. That loss happens, and that loss means water that is responsible for gaining strength of concrete because of chemical reaction, that is reduced. So that reduction is harmful to concrete, because until that deficient quality of water, we have to replenish that, and to replenish that is called water add to concrete, which is called, or to add water to concrete, that is actually not added to concrete, that is spread or supported. But concrete receives it, or we spray on concrete, sprinkle on concrete. Only that loss of water due to evaporation is compensated, and concrete gains its strength based on chemical reaction between water and cement. That is sole purpose of that. It has nothing to do with further rusting of steel once it goes in, but already rusted steel shall certainly proliferate itself because of water, and opportunity is got, and we are saying we have to understand this analysis ourselves. I cannot expect those professional courses like me. So I think you are clear to what I wanted to communicate about this issue of we can say massive block concrete. It is very important part, because if you do it once or understand once, you can improve quality of concrete on such plants. And other point is that replacement of OPC is also very important part, and people have to realize this fact. Do not take it easily. It is a very serious issue. GGBS has to replace cement. Cement has to go to say up to 70% of its design value, and GGBS will replace with that for making better concrete that works against, and that works to improve environment, that works to improve temperature, and to now you can simply say GGBS. You have to understand, I talked many times about that. Again I will give some talk here. GGBS is ground granulated blast furnace slag cement, and it comes from smelting iron. It's very remaining compound there, and it has many chemical compositions in that. And it's just like you get fly ash, it's also same. This gas comes in, but there is a tolerance in this. It's flexible material. Flexible means it's better than in process. If you compare to fly ash or pulverized fly ash, there is a limitation in fly ash, more than which you cannot grind it. Means to one state, it doesn't grind further. It can't be made more finer. This means we cannot increase fineness of flyness. And fineness depends on specific area, and specific area depends of as much as you can grind it. But there's a limit in your PFA. It's called pulverized fly ash. And if you study GGBS, there's a room that it can be further ground, more and more ground. This means we can use this finer and finer in some cases, and also keep coarser in some cases. But finer and finer means increasing and increasing your finest model, finest area. That finest area is very useful, because means you can grind as much as you can. You can grind is more and more and more. There is no limit. You can make it better and better and better. There is no limit. And as much as you do it, fineness increases, means its reacting power increases. It cannot react on its own with water, but when it comes in contact with cement, it works well. It works much better than cement. Because cement, you do it, scan it, and you find something happening. So you can change, you can replace your, you can replace your OPC up to 70% by GGBS, but you cannot replace your OPC by PFA to that level because it does not perform more than some percentages. So therefore, we use GGBS even up to 70%, or in some cases up to 80%. 100% you cannot replace because this is not independent cementing material, neither PFA nor GGBS. These are having support to cementing materials, you can say that way. These are not cementing materials like OPC or SRC. We cannot cement, these are supportive, non-supportive material that they do same thing as cement does when it comes in contact with cement. That is where victory is. Means if you take case of one bag of cement, that is 50 kilogram, we all know it releases, if it is OPC, it releases 46 kilogram of carbon dioxide per air, 56 kilogram. So if you take case of this means you can use 70% blast furnace slab. You can ask anybody to go to distance to buy it. Maybe you have to buy it from some other state that you have to arrange, but it's not expensive. Maybe it's expensive in transport, but it's not expensive in here. So let's now move forward and see how gas transfer works. Another benefit of this is that when we use GGBS, we reduce the quantity of OPC to 70% to 80%. This means we reduce that quantity of carbon dioxide released into air. And because it doesn't release carbon dioxide, your GGBS, it's different type of material and it reduces carbon dioxide and it's replaced cement OPC, and also it's of same price, I think not much difference. Transportation may be heavier, but benefits are that first of all it reduces setting time. I mean to say increases setting time initially, but later on means it's little slow in setting, and which is interest of construction, because immediate crack formation is avoided. This is hair cracks or cracks like that. It's a slow setting. So slow setting means curing problem that is done in panic is avoided, because even if you delay half an hour, it doesn't make difference. Or even if you wait, depending on weather conditions. Certainly initial problem of curing is avoided, and you can say, of course you have to keep your formwork, particularly horizontal formwork, for a little longer than you usually keep. But cracking problems, solve this. There's no question of cracking, and there's no question of worry of cold joints, because the initial setting time is longer. So I think you are out of problem of cold joint and even flashing, flash setting. So you cross many problems. If you replace this, of course you have to give more time to assistant. The final time means maybe it takes approximately 1.5 to double time for final setting of concrete, because you have to wait for that, then you have to post testing, pre-testing or post testing, for post testing is access to ESC. Post testing also very important. That's post testing. Post testing is very these points we have to understand very, very clearly. It's a very technical point, engineering point, and you know, draw a relation. We lose certainly something, and it's not a lose. This is you are going to be 70% you are avoiding carbon dioxide. What else you want? You know how many bags are used every day in this country? Now maybe down, but millions of bags are used sometimes all over this country. When construction are in peak, so how much quantity of carbon dioxide that we have raised to environment, and harmful effect of that we have. So I think that we should be serious about this. It's very much part of quality. We can solve many such cold joint problem, other problems, and honeycombing problems, and also we can do a lot in our health. We are theoretical people. We never go through what journals are issued, what are issued. We just keep on moving, like as if we are layman society, lay people society. Engineering element keeps missing from us. I don't know reason. People are little different. They don't want. They just move on and on and on. We be careful of that. That's all I can say. So coming once this was about method statement, I want to talk to you. So, and I would say that before concluding, before water and ink or food. So now go to other part of our discussion, that is contracting. Contracting. We will discuss more parts in construction. Construction is something that has no limit, I can say. It's different one, and we have to be very serious. We have to really be serious about that. And put that on. We have to be very serious about that. And when construction is concerned, this means contract is concerned, certainly both have direct proportional relation. Without contracts we can't do, though we can do, but who shall take responsibility? The question is that who shall take all this headache? We want to administer only, we want to supervise only, we want to instruct only, we don't want to be instructed. That's it. And when we do ourselves, I think that who is there to instruct you? You have to instruct yourself. There's no, your senior may instruct you, but if there's a contractor, you think I am big, small, at that point. Do you think it's possible? I don't think it's possible. It's against contract ethics. We are small and big, this doesn't work. But our mindset is sad because of our slavery experience, and And our thinking, I am paying you and you do according to this, but contract doesn't say that if you read contract. How many people have chance to read, I don't know. Not, I think, not less than executive engineer, somebody else has contract. SCR, might be they read something in the past, and they are small, but in those days, there were no website at all, or if they used to use something. So we have to be smart enough as far as this is concerned, and if we do not act smart, we certainly do something seriously. There is something that needs to say. Contract, when I start, contract is beauty of construction. Contract is tool of construction. It is bridge of construction if we cannot use our own skills of construction. I say, I claim every civil engineer has a skill of construction, but that civil engineer is not ready to share it, to respond to that. So what can you do? No senior engineers in civil up to rank of chief engineers, they are interested in doing job themselves. They think and they are experts in all of the things, but they are not experts in some. Sometimes I enjoy about contract and imagine there is no contract. How can we work? Wonderful. We can work very successfully, but we should have will for that. Leave it behind. Why should criticize? It's not happening. I can't change world. I can't think everything idealist because development is not one person's job. It's job of all. That's why we are there. But even if you are in office and you go to business from office sometimes, you are not able to speak facts. You are not able to speak with your voice. It's like it's happening now. Our video, our children, So let's go back to contract. It's just another hour, not only half an hour, 40 minutes, I can say 40 minutes or 45 minutes, let's see, 45 minutes, maybe I take up, maybe what's that actually? When I say contract, first you have to understand contract. You don't understand or you understand, you have to decide yourself. Why contract? My question is why contract? Just like my question is, so what is engineering? What is engineering? Is contract a part of engineering or is not a part of engineering? That's another question. If there is no engineering, can there be contract? And if there is no contract, can there be engineering? There are so many questions. Forget every question. Contract, simple terminology. Is it rocket science? We have to explain what is contract. Or it means simple motion of two parties on same track. Two parties are moving on same track. or you can say engine is there, one wheel on this track and one wheel on another track, one wheel on this track. So, oh, how many wheels are there? Half on this track and half on that track. And this engine is moving. Is engine what? This engine is what you say. This engine is contract. This engine is a creation, or you can say is created by these two group of wheels, one in ascent and one in descent. These wheels accepted that we shall move together through this mechanism, that is engine, for this purpose. That is the final mechanism. So I can say, yeah. Contract, move together. For what? For one goal, and that is profit. What is there? What is there? Tell me. But there's nothing. Contract is nothing in fact. What it is? Big problem. Big problem is what? Problem of administration. What do you mean by administration? Where is contract? Yes, that's the point here. There is no administration in contract, but contract requires administration. Contracts are well defined, clauses are well defined, but administration is a problem. Who is the administrator? Point is that. Who is the administrator there? There should be IAS administration. No, there is no IAS administrator here. There is a party defining, which is administrator, and that party is engineer. Engineer shall do this, engineer shall accept this, engineer shall reject this. You have to submit to engineer, engineer shall notice to you, you shall notice to engineer, this shall happen, this shall happen. These relations go on engineer contractor, engineer employer, engineer contractor, engineer approval, engineer rejection, engineer. Who is this engineer? This is administrator. That is contract. Right or not right? Engineer. We need engineer or administrator. People object. Why engineer? What's your problem? You are objecting. Don't object. Engineer is expert of profession. You are expert of your profession. Do your profession. Our engineer shall do it. Don't talk. Administration of what? Question arises if he is administrator. If the engineer is administrator, engineer is not a party. He does not sign a contract, but he is administrating. Without him, nothing can move. Your employer cannot move something, contract cannot move something. If engineer says stop it, engineer can say the both parties, either parties. Stop is, I am doing, I will do that. Okay. So, engineer is an administrator. We understand. Engineer has to administer this contract. This means engineer is like a top class secretary for this contract, because contract is like a specific law for this project, and laws are operated by secretaries everywhere. Purpose of secretary is to operate law. Do you know that? When we say secretary, first secretary, second secretary, general secretary, what does it mean? This doesn't mean clerical position. This means you are responsible for laws which your members have decided. Your institutions are there, but related to business. That point is very important that we have to understand. The scope is defined in contract. Contract is not simple document. I'm just telling you, it's not simple document. There are so many documents involved with contract, and that's why engineers require. Those are not exhibits. Remember, those are not exhibits. Those are documents. Therefore, responsibility is owned by engineers for that. Fabrication of contract and support. These are not evidences, these are contract parts of contract. One is form, as I said, contract form or contract format. Then there is scope of contract. Then it comes section various triangles, dice, and dice. And also there is particular condition. So we have a contract. We have to administer. This contract has further contract. It has standard bond with it. It is a contract bond. Standard bond of expires when the contract. Performance bond is there. Price of contract is there. Performance bond is there. And then you say some other particular conditions are there. Then general conditions are there. Then you can say particular specifications are there, projects are there, general specifications are there, and then many more documents, whatever you agreed, correspondences, and finally everything is there. So all are called contract documents. Drawings, of course, I forgot to tell this last document, but remember, is last one, not first one. At end it comes after specifications, drawings comes, all drawings. So this is very complex nature of contract documents. Maybe people do not realize this fact. Even in a program that you are going to accept, contractor, employer, not engineer, that program shall become an integrated part of contract as well. Though it is changeable, but it's going to be a regular part, still like contract. So this all foundation of this permanence of the documents is very significant, very rational. That point we should not forget. Once we understand that our contract is so heavy, then you think some ordinary person can control that. Means it's in hundreds and thousands of pages probably. You know that. Drawings are also counted, specifications too counted, codes are also counted, which are not every code of your country or whichever you agree on that are listed in there and then. So this is a contract comprising of many thousands of documents. Do you think is there some law luminary who can control this? There is no luminary in this country who can control such documents. Even our top class judges, they cannot control contracts because only narrow studied person who is engineer goes into blues, who goes into very analytical study, only that person can do that. If you see a judge has 50 documents, he wants help of some lawyer, come on, help me, how to do this. But engineer does not do that. Engineer sits down on that and study each page, and otherwise he cannot understand that. You cannot understand through someone else. This is technical matter. This is engineering theory. This is mechanical theory. This is electrical theory. This is, civil theory. This is surveillance theory. This is SCADA theory. This is, you can say, building management theory, building interface theory. What is not here? Engineer can understand. Of course, I cannot say civil engineer can understand everything, but what is written can be understand. It can be raised. It can be discussed with mechanical engineers, with electrical engineers, with other IT engineers. It can be discussed with everybody, every vendor. It can be discussed with. We understand as civil engineer what's voltage. We understand what's amperage. We understand what's watt. We understand what's kilo horsepower. We understand what's the MPa. We understand, Kelvin. Every unit we understand. So this resistance, reluctance, ohm, mho, all we understand. It's part of our syllabus. We forget that something else was applied thermodynamics we understand, heat flow we understand, heat quantity we understand. Oh, what is this machine? What is that machine? What is the equipment? What is that? What's this pump? What foundation it requires? How much it requires? That we understand. So when we understand everything, why don't we claim that one? Why do we run away from that one? That my field is civil engineering, not this. When you are on contract, you have to deal with everything. I'm not saying you'll go to market buy ice, but you know how to work on that. Contractors have a tendency to raise certain issues which should not be raised, but because of some time buying they do it. They raise issues for something, at least they will not say why I do not submit this material. So raise some questions of technical standards or technical orientation that I'm not understanding this, please explain to that. Though it's there, answer is there. Happened with me, I was office engineer, and all these variable questions, they are to raise queries to come to me. And one big person of the auto, HVAC, I think HVAC or someone, yes, that sent some query, it came to me through our directive. Okay, make a query and send to related consultant or partners. I got through that. I tried to understand myself because I cannot send something under my authentication if it's not correct. That's my rule. And my director didn't say you don't study this. You just study and make it. So I just studied for 10-15 minutes that one, not more than that. So what I said, there was a question about some heat mechanism. That raised some question about the technical issue. This information is not available, that information is not available. Everything was available. I see the graphs, helicopters, this was available. This answer here is this. This is answer here. I wrote that. Answer is available in Selector. He reached director, director called me and phone said, what is this your answer? Who has answered this? Did you go to that? Who did consultant answer? This alliance answered. No, I have answered this. You have answered this. He did not ask why. So this contractor did not read that. I don't know. How could it be? You see yourself. Am I wrong? No, you are right, it is there, but how come he said that? Such types of these people create problems. It happened to me once in Saudi Arabia. There was rejection of lift. Lift for His lift submission, there was a rejection for many times lift and some right terms. Then again, I think it was fourth submission, fourth something. I just joined that site. His previous manager had gone, so I joined. And these people were just complaining, all our construction manager and this our owner even, who was not an engineer doctor, so he could not understand the contractor. So this consultant, this Pakistani consultant was there. Oh, see, this man writes this comment this time. Then we submit again, he writes another comment next time. This Pakistani consultant is useless because he should write one time what we have to do. I will listen, okay, come on, we have a meeting, I call him for meeting. Call not consultant, party, this party, Arabic party. Come and discuss with him. He was in meeting and our construction manager was meeting and somebody else was working. He was complaining against that Pakistani consultant. This consultant, this. I have done what he says I do it, what he says I do it. I listen. Okay, your turn. Now answer me. Whose manufacturing is this? Yours? Yes. Whose structure is this? Ours? Yes. You have structural drawings? Yes. You are complying quality management or not? Are you ISO 9000 agency registered or not? Yes, we are registered. Even if you are not registered, what's your duty? You tell me, is this consultant your servant? Are you paying him? He said, no. So why should this consultant work for you? You are charging money or that person is charging money. This is your machine. You are responsible for his performance or that consultant is responsible. Why do you blame that consultant? First you tell me that. He was like this. You don't have staff. You don't have engineer with you who can go through specifications, who can go through conduct, codes. Why do you expect this consultant to help you? If that consultant writes to something, it's your help. And you are complaining on that. You are expert of your field. You do, in first time you bring something professional. Why should there be some comment? It's your weakness. Why you command that person should write one time? Who are you to say that? You are right. I will check it. Don't mislead our construction manager. Don't mislead our owner. This is quality world. You cannot mislead everybody. I don't expect for my work, I am main contractor, that this consultant should help me. Because I am not paying to consultant. That consultant is serving a client. That person is serving to administer contract and supervise this job, not to help me or help you. If I am doing something, that's just to save time and to help you to move job. It doesn't mean it's your right. You're complaining. Learn it. Take this time back and this time you bring right time or I will not approve that. To go to consultant, right? Yes, people don't understand. They just take contact and jump and see, he's not approved, he's not approved. Why are you telling your honor that this is not happening? Your honor is doctor. He does not understand this contract. Why do you complain to him? And this construction manager, your friend, my employee, he is also supporting you. Why? He doesn't understand contract. He understands contract. But because he has something to do against that consultant. This policy shall not work until I am here. Do your job. You are paid for that. I am doing my job. I am paid for that. And that consultant is doing his job, is paid by client. He is thinking, client, not for you, not for me. There is a system for everything. Yes, you can be helped provided there is some problem. You can raise question, no doubt. I will raise this question. You give me this is a problem, this is a technical problem, drawing is not clear, specifications are not clear, this ambiguity is somewhere, direction is not clear. We can raise question on that. If there is some conflict, there is some clash, there is no clarity, or some technical parameters not available, but don't forget this is your machine. That's what I'm saying. There's a difference. Your machine, not defined machine. You are defined there because they approved your system somewhere in contract documents. They have listed you as expert manufacturer, expert vendor. So where is your expertise? This means you are not expert. Should I write down that recommendation to ministry that you are not expert manufacturer? You have just got enlistment there. You don't understand what is consequence of such thing. When you got approval on official list, your responsibility. You solve this problem, you calculate stresses, you calculate everything. You see how your machines will behave, you see how it's competent to structural requirement or not. Why do you believe? Why do you depend on? You give complete details, his father will approve. Don't complain, 4 times I have submitted. No need of second time. It shall be approved first time, and I assure you, bring everything at first time. What happens actually? These people want to override someone, overload. What happens? Okay, tomorrow is my day. I have to submit. If I can't submit, there shall be question meeting. Okay, submit is at this. And our manager, submit is at this. No study. No study. Why? Are you sitting here just to submit without studying? You don't want to open drive and see even what is there. Maybe section is missing or wrong section is there. You are an engineer. Doesn't mean you should be mechanical engineer. You can read English. You can read drawing. This drawing is based on your drawing, your structural drawing. He has not invented new drawing for that. He is fitting in something in there. So you can't do your work. This means sometimes we play with nothing per se. And particularly those people who delay works, they play with this. Those who are systematic, they never play. They bring in complete professional calculations, and that is approved immediately. Problem is time, really speaking. You are so busy, or you are so occupied, or you have so many contracts and lack of stuff. You want to give 10 times more work to someone, and that's not possible. It happens in practical field. This is engineering. This is not something else. This is not call center. This is not quality work. This is engineering. In quality there is no responsibility, I know, but in engineering there is a responsibility. In quality you have to supervise, go and see, okay, it's wrong, it's right, I reject it, that's it, your job is over. You are not taking any responsibility in quality, but in engineering you have to take responsibility of design, responsibility of revision, responsibility of recording. You are going to take every responsibility. So when you take a responsibility, you are called engineer. Who called quality people engineer? Nobody called inspector, they call them. You know that. Even if somebody comes big, inspector as them. Because they themselves have not proved their own engineers. They will say, this is right, this is wrong, X, I reject this. Give solution. You give solution, they say. Now I write to you what should be done, and you learn from that. You are quality, you are educational quality engineer. You suggest me what should I do. Your method is statement writing responsibility. I am writing. Method, construction method responsibility goes to quality. Everybody knows, but they say, no, you write it. So we are under compulsion, we have to write. What's use of writing? They say because they don't know what to do. They learn from our method what should be done. They are not criticizing. It's because they only know some limits. Beyond that they cannot do. They cannot do beyond that. There are some practical problem. Quality is engineering actually. It's not separated. But virtually it's separated. Oh no, I am an ITP, that's it. I know only my ITP. I don't know more than that. This is checklist and this ITP. According to checklist and according to ITP, I am responsible. I design ITP, and they design in such a way that they should not be trapped. You see, whole point here and this point here and that point here. They keep themselves out from responsible play. But they will do data work. All data they will give. Everything they shall give. Everything. I started as office engineer, then I thought I am part of quality. I also thought that. I thought I am part of construction as well. I thought I am part of planning as well. And like that, I thought I am part of contract as well. Because I am office engineer, I'm dealing with everybody. I'm a coordination engineer, you can say. If you are a coordination engineer, you have to coordinate with everybody. It's not that I coordinate with this and leave this one. So when I used to go with that, I decided to see this query I'm writing. Is it okay for you? He didn't read anything. What does it mean? You are deciding. Okay, for construction, I need not any. Construction guy came to me to make that query. There's some problem, make query for this, and planning has nothing to do with query, so I don't wish for quality department has nothing to do with query. But you are involved with that, means whatever you are sending, you think you have an answer for that. I take it to you for that purpose. I could not find answer. You are a quality person. You are directly dealing with that activity on site. So maybe you have some answer. If you have an answer, I no need of sending this query. But if that guy says no, send it. So I need not your help also in that. So I stopped going to them. What's the use of that? No use. Same way for method statement also. I deal with construction people and see specifications, and because they did not read any, those people don't even read specifications, they just approve or disapprove. That's not quality. If you want to maintain quality, you have to study, you have to enter into depth. Just signing or rejection, off sign, I signed off. Oh, this is rejected, give method statement. You give method statement, how I have to do this? You did not give before doing this, and you don't go after doing this. What for you are here? Just to go to side and see rejected? No. You have to help construction people because you are educated, elevate, you are an elite class, that construction person, foreman or supervisor or site, that they are not equal to you. They are much lower. So you tell them, but it is not happening. That's why there's a problem. Argument for sake of argument is no answer. I don't consider it as an answer. Oh, just sitting, I told you do this, you did not, I told you this, oh no, you agreed this, you are denying this. This is childish behavior. Do not be child on job. Talk maturity. If something is documented, well. If it's not documented, there's no use of argument. Document tells you what to do. And quality is nothing but documents. If you talk of quality, what I understand from my experience of life, we used to same documentation before also. Before, when there was no quality system. I'm talking of 90s. When there was no quality system. I'm talking of 80s when no quality system. But quality was there. Because everything was documented. No IS 9001. Everything was done. Everything was recorded. Inspections were recorded. Everything was recorded. Statements were recorded. How much cement consumed was recorded. What quantity were recorded. Everything was recorded. What has happened now? Only acceptance, rejection, action. Reject, accept, reject, accept, reject, accept. Where is record? Yes, you have record of what people are doing outside. Now you don't have your record. You don't have your record. So that's the difference. Well, system is like that. I can't help it. More and more changes are there, and now at least something has been done by ISO 9001 2015 that those who are in higher positions, they are also held responsible. Now this better. This I can support it because before only quality head was responsible. So everything responsible goes to, oh, I'm safe, I'm MD, I'm safe. You are MD of what? Question is, you are managing director or your chairman, say, you are executive, someone director, for what you are there? If that quality small guy is only responsible, you are not responsible. You are only there to make money, is it? If there's some accident on site, then the safety by responsible, the site engineer responsible, you are not responsible. What for you are there? What's your connection? What's your personal name in that contract that you are here? Your responsibility is there. So IS 901 says everybody is responsible. That point we have to understand. You cannot leave only small person under problem and you escape yourself. Then what for big? You are not big, you are small. So in 2005 there's some change and responsibilities of quality people has degraded, and those in higher echelon, higher hierarchy has been increased, and that is to some extent appreciable. But shall it work? Question is that. Shall people understand this? That is a question mark. How much is effective? I don't know. It's already 5 years around. It started somewhere in September 2015, and I think almost 5 years are over. How much it is effective, I can't say. I have no statistics about that, and neither I have seen on ISO 9000 sites something in that connection. And if it's not, then it's a question mark again. Now, where is control of ISO 9001 governance? Through their registrars, those registrars who audit every company. If they also audit for sake of audit, then there is no system except documentation, and documentation also are not very mandatory. It's up to you which documents means you want to manage, but you have to just establish fact that you are following certain system which is on document. It's not mandatory. They will not ask something, give me safety plan or show me quality plan or show me this plan. You have to decide, means party has to decide itself or what documents it wants to accept. You just give them a procedure, your policy, something, what you want to run. Other documents are optional, whether or not use them, and if you use them, you have to keep them and you have to prove them you have used. Way which may you get credit, of course, for certification, variable, but it's not mandatory. Just like documents control was called documentation, now it's called something else, previously it was some mandatory provision in that. Now it's not to that extent. Document control was mandatory, lists documents were there with which you have to do that, but now it's been left to organizations. So there's a lot of difference. Means I think they might have discovered that it's not done, so there's no meaning of doing or writing that, because it brings a question to registrar as well. So after all, they have to submit some report, and that report must have been intimated to, after all, this ISO 9000 organization, that is not happening. There's little compliance on this. There's or no compliance. So question, of course, comes in. What's purpose of that procedure that can't be complied? And if majority of people do not comply that, this means that is void. It's what's purpose of maintaining that provision. So it happens that say remove this, leave it to option of people what they want to do. Our purpose only that whatever they describe, whatever they include in their procedures, they comply with that or do not. If they don't include them procedures, then they keep them secondary documents or optional documents. Let them see if they can do that also or not. Means we have to evaluate their performance based on such system, which is mandatory as well as which is optional. So means there also this quality system is not independent actually, to be very clear. It depends upon what parties are doing. You cannot, there's no control, so the disclaimer is there everywhere, because we are only spectators, we are only observers or auditors, so certainly they don't have any responsibility because they are not directly involved. But those are on executive front, means on sites, those quality people, they are directly involved, so they must take responsibility. And if they don't take responsibility, how can you expect MD to take responsibility or someone else to take responsibility? That is, Hawk's statement. If I say, no, you are responsible, and same thing I say, oh, you are also responsible. But how you are responsible, they have not pressed at that statement, that description, just saying, okay, that will be considered responsible. What way? You have to write that in procedure, or you are not to write in procedure. That's the point to be considered. Which managing director like to say that I am responsible? Nobody. challenge. Nobody will like to say, I am responsible. You are working on site, I am not doing it. How can I be held responsible? I can give you money, I can give you permission, I give you a sanction, that's it, not more than that. I can't be held responsible. So no one shall take that into procedures. Everybody shall like to risk out to escape of that risk factor, and that's policy of these people. So I guess that something is ridiculous. So that's all. Based on my experience, I can laugh because it's happening. I have full right to laugh because of negligence of our own colleagues. Nobody wants to take direct responsibility. They want to leave it to people on site. Even designers leave it to people on site. They are responsible in designs, but when design is fail or doesn't work properly, this is site people did not care for. This site people did not care. They say like that. It's generally statements, maybe investigations or else. When something comes on your head, you say, no, it's site people. I know it's beyond my control. How is not beyond your control? But you can say, why do you take sub-control where you do not share your control? So you should, at time of design taking or accepting that control, you should write this clause that we shall take responsibility only where involved. Otherwise, have you avoided that clause or you have included that clause? That shall tell you. If you are avoiding that clause, this means you are not even designer for that project. Design for sake of design only. One who is implementing that design is also design, because the professional engineer on site also design. So if you are saying, no, my responsibility, that person will take, then you should not be paid full fees. You should. I have seen design contracts before. Yes, we will be part of your meeting, and whenever you call that, you will notice and will join, send us your design related success or failure reports to us. Did you include those conditions or include those conditions? That's a very big question mark. We should not reject that. We should not say, no, it's not that. No, it says. If you want to improve quality, you have to take those points into considerations. And if you say, no, we are not concerned about quality, nobody can answer you that. But in our country, who knows all this? People don't even understand contracts. They say, oh, this is contract. There's so many price. This is my price. I know this price has come to me. What is there? I don't care. What is there? I don't care. That's the real answer. There are many people sitting in offices, government offices. I will get my bill clear of this. So why should I worry about this? About safety? Okay, some safety. I will do this and that to show hard hat, to show yellow jacket and overalls, and some work without compaction. I have seen even backfilling is not compacted, and they just do anything they want. Water is lying in trench for days, nobody cares, nobody bothers. Put concrete, that is water is lying in trench and nobody cares. And rusted steel everywhere, everybody sees it, unfortunately. All see it and they use same. And my conscience really weeps on that, because this country, where is governance in this country? Where are engineers in this country? Is department not having engineers? Is a contractor not having engineers? Where is problem? Everybody paying. They say we have so many engineers. They see their advertisement. Oh, we have a group of so many engineers and foremen and experts. Where are they? Where are they? If your ground is not telling, you, it is that is work according to standards, where are those engineers? This is really, I can say, is a question mark, and nobody has answered to this problem, unfortunately. I'm not blaming government on this, because government is not engineer, but those who are, they are careless. Nobody is raising any question. Why quality is falling? If you see only one point, I tell you, if steel is rusted and you are using it, this is clear indication, because no element more than RCC in consultancy, our structure and designs, it's more important. Steel reinforcement, carbon steel reinforcement. Our water is entering into that, oxides are entering into structure of steel. We can't see, but it is entering using microscope. You go into that, you will find carbon there also, and now moisture is there, and moisture takes many chemicals also with it. So of course water is there, carbon dioxide is trapped in steel, and you're putting concrete on that. What shall the bond? First of all, bond doesn't exist with concrete. Steel bond that should exist. It doesn't work with concrete, but you are doing that. If this part is not visible to people, what else? Who bothers about bending moment and shear force and deflection and hogging and sagging and this and that and micro crack and this, if you can't see this? Who goes into that depth? Nobody shall go into that depth. What is durability and what is fire resistance? All that is secondary. If eyes can see something and mind cannot act, then quality is zero. I can simply say, and I can say it is general observation all over this country. Maybe in certain cases I can't say, maybe in very prohibited areas I don't know, but as far as this is concerned, in general, contractor works or Faridabad smart city or many other smart city or how private works are doing, I think it is unique country where people don't bother about, they don't bother about anything, they don't bother how they are mixing concrete, they don't bother how they are mixing mortar, how much water is to be added, nobody bothers about anything. These are very elementary items I'm telling you. I'm not talking high profile items, I'm just talking very small items that count in engineering. And if we can't do that, what we can do? Really, it is very much annoying to me, at least being an engineer. I have seen many countries and I have seen my country as well. I am fed up with my country, really speaking, as far as engineering is concerned. It may be a small project or maybe a big project, there is no difference as far as quality criteria is concerned. ISO 9000 is just for tie, I'm wearing tie, I'm a smart person, not more than that. Just a badge here or badge here, or I have cap here, not more than that. This is not working at all. Everybody is saying we are following this, but if you see product, it's not construction product only. Other products also same. It may be electronics, it may be mechanical, something you buy today. There's no guarantee of anything. What shall happen tomorrow to that product? So where is guarantee? It's a big question mark I'm raising for everybody, and I think we should be serious about that. And I will just say, because today's charter day of Institution of Engineers, and Institution of Engineers, a pioneering official body of this country, it should not do anything other than quality management control. No use of seminars and congresses if you cannot control this quality criteria, and that's what I can say. It's very important for everybody to understand this. And if we do not do justice to ourselves, we do not respect God, if we cannot maintain quality, it's a part of worship, I can say. No need of going to temple, maintain quality. This is more than worship, because you are spoiling natural material. It's not your material, believe me. Steel is not produced by you. Yes, it is in processed by some factory, but original steel comes from fracking. That's natural material. That part from your steel, so how many times that material of ore was, so you have destabilized that ore for this steel. You have processed it, manufactured it, but the quantity of ore that contained this has gone forever, and you have caused harm to natural availability of material. This means you have acted against God. You use this natural material. This is not your own produced material, and you are not doing justice with God. God's items, God's earth products. How can you do justice to yourself? So you have to answer to yourself first. To your soul you have to answer. To your mind you have to answer. You have to answer them to society, and then you have to the nation, and then we reach there. You have to answer to that power also. But I abused your material. So that's what I say. Quality is very important criteria. It's not simple spelling of quality. It's really equality that should be there. If quality is available, there should be no complaint at all. Means everything should move, but it's not happening. Not at all. That's really worst I can say. I find big difference where there's quality control available and where it's not available. It's very drastic. It's really abusive. Basically, self-destruction, I can say. It's another kind of virus, in our country. That quality, this means negligence, which means ignorance, which means sin, which means, non-professional indication. Though we are all educated, very well educated, I think 80% of Indians are MTech or PhD. I am not, but they are, and they should be smart enough to speak, but they maintain silence because our engineering studies teach us silence only. Maintain silence, don't speak. And this is standards of PhD and MTech engineers. They may be very in a high position, they may be chairman or president of some institution, they may be council members, but they cannot speak against this. So what's your purpose? If you cannot improve your profession, what for you are there? Your liability on yourself, your liability on institutions, your liability on society itself. There is no purpose for you to be there, but you are there. Unfortunately, it is really, and I'm sorry to say, that overhaul is required. It doesn't matter what's your qualification. It doesn't matter what's your degree. Matter is what you deliver. If you can't deliver, you're meaningless. Your education is meaningless. Even if you're BE or ME or PhD, it's no meaning. If you can't deliver, people can only say, I am this, I passed MA, PhD. Where is this? Demonstrate it. You are. Your work has to tell. You are that. If that's only for certification purpose, okay, that's fine. Congratulations to you for that. Then don't claim that. Work, state of concrete, state of engineering doesn't tell that we have so many highly qualified people available in this country in proficient sections. They are available, but not in action. That is very important point we have to really take into consideration. In that case, I will say diploma is better, at least that person is not telling is qualified enough. And that person does what you say, so his job is only to follow instruction. But where is the mandate of higher level, your chief engineer or your managing director, and then quality is bad. So you are not there simply saying your body is there, your efforts are not there, your professionalism does not exist there. Only that I can say and nothing else. And I should say that I have no words on that. And really, it's very well annoying statement I am giving. Improve quality, that's what I want to see in this country. And I feel ashamed when I find difference of quality in ours and where I want. Lot of difference. With this I would say thank you very much everybody on this day of Charter 1935 and coming 15th September, Engineers Day. And thank you very much. Sorry for annoying you. I hope you understand reality. And rather than speaking, we have to create an environment that we do something that is more important. Thanks again. Thank you very much.